Hola, hola, hola. Muy buenos días.
Hello. Good morning. I'm going to really have to tell somebody off. Let's start. We're going to begin the second day of the Congress. And those of you who are not from Granada, I hope you enjoyed your evening in the city. And let's see if we can kick off day 2 of the conference. Good morning. Welcome to all those present. And I'd also like to welcome everyone who's following us via streaming. And first, I would also like to acknowledge the service that's been provided by the interpreters, who are helping us to ensure that the translation is received in any part of the world. So welcome to day 2 of the ISVIS 2023 Congress, and based on the knowledge and experience that we gathered yesterday, today we're going to move on to other themes and topics that are equally interesting. We're going to start with Block 3 on sustainability, circularity and energy efficiency in the the residential housing park, which is consolidating the concept of sustainability in the construction sector. And this is going to be the first objective of this section. We will highlight the importance of experiences that are committed to the materialization of sustainable development goals and principles, which include the conservation of resources through the use of proximity materials. We can highlight, for example, the presentation of experiences in decarbonization in the sector, zero carbon initiatives, and the use of sustainable and innovative materials. In addition to these, we can also include models which are consolidated based on the principles of the 5 R's: reduce, repair, recycle, recover, and reuse, with special emphasis on those initiatives aimed at promoting the circular economy through the development of the life cycle of materials and, as we always highlight, their recycling. We will learn about examples of the improvement of energy efficiency of buildings from the perspective of energy rehabilitation and also the integration of renewable energies. And the structure of Block 3 is similar to that of yesterday. Just to remind you, we will have guest speakers before and after the first coffee break. There will also be a technical presentation by Avra, scientific presentations, and also a roundtable on best practices. We will kick off with the first presentation, which will be given by our guest speaker today. The speaker is Valentin Moreno. He's a professor at the Faculty of Economics and Business Studies at the University of Granada. His lines of research are based on circular economy, sustainability, and the inclusion of people with disabilities. He's published papers and book chapters on the subject of sustainability and circular economy. He also teaches as a professor on master's programs in different Spanish universities, as well as universities in Latin America, the Balkans, and Caucasus. He's also a member of different European projects. In addition, he also participates with the CS Foundation of the SECAP group to generate new job opportunities based on the circular economy paradigm in order to create new jobs, which are so necessary. Inclusive employment. The title of this presentation, Circular Economy as a New Paradigm for the building rehabilitation sector. A round of applause for our guest speaker this morning, Valentin.
Buenos días.
How is everyone? Are you all raring to go? First of all, some words of thanks. Well, I love teaching, and the opportunity to participate in these type of conferences Buildings are assets that ensure that people can live better and better as a society. So being able to share at least a minimum amount of our knowledge and experience on the question of circular economy is a wonderful opportunity, because I'm sure that we can all contribute to making this a better society than the one we have. It's something that we've got in DNA, and this is thanks to our cerebral flexibility, which allows us to contribute the best that we have to offer. The circular economy, well, the term economy is a Greek word which refers to data management. I apologise, but the gentleman's got to speak close to the microphone, otherwise we cannot translate. And 12 years ago, when we began to modify the conditions regarding the general balance on our planet, we began to, as a species, began to develop words which would facilitate our survival. Why did we create the word economy in relation to the I apologise. We are not telling you to move on. Please, could you speak close to the microphone so that... Oh yes, I want to speak very loudly. Can you hear me? Es para nosotros. They can also give you a roving mic if you like, or even a lapel mic if you like. No, it's fine. You've got 1 more minute, so I apologise for interrupting you. This is a bit like in European competitions, isn't it? Thank you. So why was the concept of economy or economics created? Well, because humans began to realise that resources were limited and scarce. We all know about how old the Earth, the planet is, and our universe. And in 150, 160 years, sapiens will have phagocyted the majority of the planet's resources. A planet and a university, matter, which is limited. So we created the concept of economics to help us to manage scarce and limited resources in order to satisfy the endless needs of sapiens. There are 8 billion inhabitants on a finite planet at present. So look at this figure. I love to visit a geopark in the north of Granada at the weekend to discover or to learn about what occurred in the Quaternary period. At 7 a.m. I love to get up in the morning to try to learn about what occurred during the Quaternary period. And many of the land in the geopark are now in the beaches in Huelva. So we can observe some very interesting geological processes and discover what could happen if we don't change the way in which we manage these scarce and limited resources. So, seen period. Never in the history of the Earth or our species has a single species so substantially modified climatological and living conditions on the planet with finite resources. Therefore, we can see what the capacity of countries is reached. Spain is indicated there in yellow. This means that every year we will actually bring forward the overcapacity of our planet because we're subjecting the planet to this type of economic stress. And the linear economy model, well, let me start again. Since the year 2000, a substantial change began regarding gross capital production and the way in which different capital economies began to produce en masse. The same occurred with in the technologies field in China, Asia, and Europe. Europe is a continent of old people, and we have less weight in the decisions that are taken regarding the global economy worldwide. And I've concentrated these slides due to the time constraints, but this slide is based on the results published by the International Energy Agency. I always recommend my students before they go out partying that they should just check on the website of the International Energy Association or agency to just check and see how much uranium, gas, petroleum, oil, copper, zinc remains in our planet. And by the year 2050, we will have phagocyted the majority of key raw materials produced by the Earth. And it's not me saying this, it's the International Energy Agency that's confirmed this. On the top slide shows us how contaminated the air is. And why am I telling you this? Well, the majority of us here have studied university degrees. Has anyone ever explained to you during your time at university what a negative externality is? Nobody. Nobody explained it to me. I had to learn what it meant after completing my degree. Let's imagine we have an economics model which produces GDP and also employment, but it also produces a series of circumstances and realities with economic value that have to be taken into account. Well, does Father Christmas tend to bring you books at Christmas or not, instead of a piece of coal? Or the Three Kings in the case of Spain? Well, this book is not for pessimists, because otherwise you wouldn't even bother getting up in the morning. It's a bestseller on the reality of our planet. You can believe what the author says, or you don't have to, but it contains the majority of figures relating to negative externalities. 1 of every 59 children born in Spain is born with autism. Why? Because we have more respiratory diseases now than before. And this slide that I showed you before indicates that in Europe we spend €1,279 on average on combating and curing ourselves from cardiovascular and respiratory diseases. And if we measure the level of environmental toxicity, who's going to pay our treatment? The factory that's producing these emissions or the public health sector? That's an externality. When we build or construct a building, the syndrome of the sick home, the sick building, these are buildings that produce illnesses and diseases. Do we take this into account in budgets as a negative externality? This is a question I'm throwing out. You're the ones that are experts in construction. I'm an amateur. Do you think that we should take into account these negative externalities? In other words, should we certify that this building is going to guarantee air circularity and that it's made from materials which are not going to produce or cause disease? I know it's very difficult to mitigate or eliminate negative externalities, but that's the aim. So when we build, and it's not me saying this, it's the news that told us that the problem exists. Do we take into account the cost of negative externalities when we build? In the compilation of articles that I'm reading, I read one which states that we're ready to pay €23,923 more for us to live in a sustainable home. An article published by an economist, published in The Economist, which indicates that 57% of home buyers would like to be able to, or would be willing to pay more if it could be certified that their home is sustainable. But what about this term sustainability? Why do Homo sapiens want sustainabilities? Why do we want to always live in structured certainties when actually our lives are all about uncertainty management? Why has Homo sapiens developed technology or created the concept of circular economy or the concept of linear economy? It's a social science which allows us to assign effectively and efficiently scarce and limited resources in order to satisfy limited needs. And what's the difference with respect to the circular economy? Well, the circular economy is a restorative economy, a regenerative economy, due to the concept of design and implementation, which uses renewable energies as a key factor for its production. And we can see the difference there in concept. When we teach economics or linear economics at university, we don't teach students about the cost of negative externalities. The DNA of the circular economy tells us the following. This is the famous butterfly shape published by the Ellen MacArthur Foundation relating to circular economy. And this encompasses absolutely everything that's important in the circular economy. But why is it represented in this way? And I will explain something that seems very complex very easily. I produce apples, and when that apple is ripe, I want this to be a biological nutrient. What do we have to do in industrial ecosystems? Well, at the Linares Polytechnic University, who are experts in materials, I started working with the Polytechnic of Linares in Jaén in Spain, and we created a subject called technological nutrients. What's the purpose of the construction sector, in my humble opinion? What will be the technological nutrients of the rehabilitation and construction sector? Will we be able to incorporate construction and demolition waste effectively? Will we be able to use materials? For example, in Colombia, we have a project, and I know that there are people from Venezuela and Colombia who are involved in that project here today. Projects for collecting coffee shells and things like this for the circular economy. Coffee bean husks. So the circular economy tells us that we should try to reincorporate absolutely everything, but everything is limited on our planet. We have very limited balances. So how can we resolve all of this? I'm going to tell you another story. A real story this time. And I know that we are tight for time. This corresponds to the cycle of the circular economy. This was published by Okama, and it's very interesting. But in relation to research methodology, the building rehabilitation sector, is it asking the same questions as 50 years ago, namely, how should we rehabilitate buildings or homes? What's the optimum cost of rehabilitation of any building? Which are the best materials to restore a building? What energy can we use to improve energy efficiency and also levels of comfort? Well, the questions are the same. The answers, however, are different. And that's why we're here today. And that's why you organise these conferences, because we continually have to find answers to the same questions. These are the same questions, and I'm saying this because this is a real example of a student who went to see a teacher of his or hers and said, "Professor, can I come in and see you?" And it was about the exams. And the student asked the teacher, "How do they do exams now? Why do you continue to ask the same questions? The questions are always the same, but the answers are different." So what we're learning at this conference is that building rehabilitation or housing rehabilitation, should it be giving the same answers as 15, 10 or 20 years ago or not? The question is whether new processes should be considered within the scope of the economy, circular economy, in relation to building rehabilitation. I've also got a master's in environmental science. This is an educational journal. But we consider that building rehabilitation should help us to combat the effects of climate change. I know there are people out there that don't believe in climate change. It's not about believing, it's a question of reading. I enjoy nature and I know what's happening because I can see it for myself. I love learning about the paleoclimate. So I love reading articles about the paleoclimate. You know, that's just me. Should housing rehabilitation help me to build a more sustainable society and economy? Why do we use the concept of sustainable economy so much? Well, because we plan to survive in the future. So why did we begin to construct buildings? Well, because buildings, homes provide us with comfort and security, safety. It's the most important asset that anyone can have, more than a car. That's why what we construct is so important. And the question that we should be asking is, should we change the way we build and rehabilitate? In Granada, we have the sustainable building cluster. It's made with polyspam, which is a material that was generated and created thanks to materials engineers. It's a wonderful type of material that consumes 200 kilowatts, incorporates geothermal energy, photovoltaic energy, wind energy, wind power. It incorporates all of these different types of energy. So since humankind in the Neolithic began to settle, we continue to advance. Can you imagine this conference in 10 years' time? And in 10 years' time asking ourselves, how can we really construct homes where negative externalities have been reduced to a minimum? And in the case of the disabled, should we incorporate sensors in the rehabilitation of homes? Should we try to generate certificates or protocols which regulate that there have to be a minimum number of sensors in homes for the disabled? Should we incorporate sensors for comfort and adaptation for an increasingly elderly population with an increasingly larger number of disabled persons? And there are three main negative externalities: the GHGs, environmental toxicity, and the loss of biodiversity. And it's not me saying this. The book on Free Yourself of Toxins by Nicolas Solea is a must-read for you because it tells us precisely this. And these books are telling us that we have to change the way we behave. And on the far right, there's a publication which compiles articles on best practices in the circular economy. And what about The Path of the Explorer, a book by Edgar Mitchell? Well, it's got nothing to do with what I'm talking about, I hear you say. Do you know why I'm showing you, though? Well, because Homo sapiens have always been explorers. This gentleman was a fighter pilot and then an astronaut. So what path should we embark on as explorers in order to build and rehabilitate in the 21st century? That's the question I'd like to leave you with. That's the final exam question. I'll then correct all the answers later on to see who's given the right answer. And I know that you are top-class researchers and professors, so that when you rehabilitate and construct a building, perhaps you have to think about the best imprint that you can leave, reducing the environmental, social and economic footprint. I wish you the best, and thank you for giving me this very short opportunity to share some of these ideas with you about how we can build a better society than the one we live in presently. Thank you very much. I've gone over by 3 minutes. Thank you.
Gracias.
Muchísimas gracias, Valentín.
Thank you very much, Valentin. And now, please come to the stage Jorge Luis García and Sergio González Escamilla. Yes, I said it correctly. A technical presentation. Jorge Ruiz is architect by the Seville University and masters in environmental management and European project management. He currently was a freelance architect, and now he is head of the team of rehabilitation of the Abra, which is part of the Housing and Building Rehabilitation Agency. And Sergio González García, he is an architect. He was a freelancer, among others, in the Office of Projects of the Town Hall of Carmona. Both of them are experts in energy rehabilitation. They are all part of Abra, and they're part of the expert group of energy efficiency since 2013 of Abra as well. This technical presentation is entitled Energy Rehabilitation Actions Financed by the REACT EU Programme, Diagnosis and Evaluation. I give you the floor, gentlemen. Good morning. First of all, I wanted to thank those representatives of Abra for allowing us to speak. And secondly, I would like to thank and congratulate those who have organized this conference. Also my colleagues from Abra, Elena, José Antonio, and the rest of you. We are going to try and highlight all of the activities that we have carried out within Abra, within the REACT-EU program, to improve energy efficiency in certain housing stocks. We're going to talk about the diagnosis and evaluation of these actions that we have carried out, these initiatives. Abra, the Housing and Building Rehabilitation Agency, has rehabilitated more than 8,000 properties in 10 climatic areas. And we highlight this because these initiatives, passive initiatives, which are the ones that we are carrying out, they have an impact on the building, and this is related to the climatic area where these actions are carried out. The first integral initiative of rehabilitation that we carried out was in Antonio Muro in Puerto Real, Cádiz. And we started to work on the outside insulation, also on the outside, on the roof and windows, and to try to do this replicate this in other areas. When we worked in Morón, as well as working on the outside of the building, we also installed solar panels. A little while after, and in collaboration with the University of Seville, we wanted to innovate in 150 housing stocks. And not only did we work on the outside, on the enveloping of the building, but we started working on the roof that was in a way that was very innovative, because we wanted to use the roof to circulate cold air and be able to cool down the top of the building. In other initiatives in Morón de la Frontera, we started trying to find eco-materials, and we substituted the expanded polyethylene. We substituted by cork, natural cork, and it was natural insulation. It helps also for sound insulation, and it has more thermal inertia. In Córdoba, we worked in 31 housing stocks, in 31 properties, in a building with 31 flats. We also try to bear in mind the climatic areas and passive measures, and we reduce considerably the need for heating. However, we generally don't manage to reduce the need for AC. When we work within climatic areas which have severe winters or medium winters, we manage to reduce the heating considerably, and that has an impact on the energy consumption. When we carried out these same initiatives in areas where they don't need as much heating, we don't sometimes manage to improve the efficiency as much as we want. That's why sometimes we have to include active measures like photovoltaic panels. This other initiative, which is the previous programs were of energy efficiency funded by feathered funds, and in this case we carried out a new evolved version of the roof. We optimized its execution and we optimized its functioning. You can see that we have an evaporation machine that injects air into the roof, and we managed to reduce it by 80% the discomfort times in the summer. We didn't manage to do so with passive measures, and with this solution, we managed to do so. In 2021, we started working with React EU financing. We have carried out 35 initiatives in 8 provinces and 21 municipalities, and we are rehabilitating and renovating 1,040 houses. This is an investment of 22.5 million euros, and we hopefully will reduce 628.15 tons of CO2 production. That is 30% less. Now we continue to work on the insulation and the enveloping of buildings, and we of course have as our aim energy efficiency and renewable energy use. So we have the case of Almería on the left-hand side and the case of Calle Curtidores in a building that is of cultural heritage. Both of these initiatives, React EU and the feathered funding ones, are managed and implemented by the AVRA personnel. Here we see that we have installed solar and PV panels. These are initiatives in Cádiz. On the right-hand side, we did, again, we looked at the enveloping. With regards to Córdoba, this building is actually a curved building, and so we have put a PV installation that is very, very interesting. Now, these are initiatives in Granada. This is the finished product, and in the bottom you can see how we used enveloping, biomass, active ventilation for each of the buildings. And so these individual active ventilation systems are very useful, and the feedback we're getting is that they're working well, and is not producing a lot of noise pollution. When we insulate buildings, we are generating a CO2 problem if the ventilation is not circulating well enough. So that is one concern that we always make sure to bear in mind. We have more initiatives here with awnings. Plaza de Estibadores, which you see here, more photographs of our initiatives. In Málaga, we have carried out 10 initiatives, renovation initiatives. In Seville, where we have carried out a stutter. And one of the things that is problematic is when we use brickwork on a building and we place enveloping, we try to keep the entity of the building. I could carry on, but I would like to give the floor to my colleague. Thank you very much. Good morning, ladies and gentlemen. Of course, I would like to reiterate my thanks to the organization of this conference. And continuing on from what my colleague said, this is the technical part of all of these initiatives, because what we want to do is have a diagnosis previously and test during and after the works have been carried out. And we have to understand what we're doing, if we have to correct or improve. And Kelvin used to say, everything that isn't measured is opinion. So if we don't measure, we don't understand, and if we don't understand, we can't improve. So we're constantly trying to find construction innovations that will allow us to improve energy efficiency, and each building is different. So In addition to the construction works, we have tendered 2 contracts for the construction of the execution of diagnostic tests prior, during, and after construction, where we try to find out where we set out and what our results are. One of our tests is a test blower door where we measure the filtration, we rehabilitate the building, and we measure how much air goes into the house before we act. And here in this test, with thermography, we can see the areas where air is seeping into the house, in this case through windows. What we do is depressurize the house. It's like a very windy day, 35 knots of wind outside. We reproduce those conditions, and this is the results that we get. And we see where the air goes into the house when we carry out these tests during the development of our construction phase. Then contractors can correct this, and we make them aware. We don't only need a certification of a great window if it's not well installed. With this type of test, what we do is detect these issues. Of course, all of this data is accumulated, and we're going to tender an additional contract for the evaluation of the calibration and blower door data and monitoring data. And what we would like to understand are the conclusions of where we're setting off and where we get to improve what we do. With regards to the blower door test, this test provides us with the N50 value. And here in a specific house in Málaga, what we wanted to do is improve the air seeping in. We started off with an N50 of 19.60, and we have reached a 3.61 value, which is an 81% improvement in air seeping in. And what does this mean for the user? We are making the house more energy efficient. When we evaluated the model with the unified tool LiDAR calendar, the tool provides a 7.12 air renovations per hour value. When we analyze the previous and values after, we obtain a better result. So where the program said 7 renovations hour, now we tell the program that we started on 19 hours, and then we get to 3.61 hours. If we don't add these calculations into the program is none the wiser. So this is a calibrated model, and it cannot be standardized for everything. In any case, with regards to this improvement, it has allowed us to evaluate the energy efficiency that it would have. The thermography report or test that we carry out before our initiatives, this is from Loja Granada. It allows us to identify during the works if we are not controlling some thermal bridges. Sometimes we can't see them, so with thermography we can. This is a building in Málaga. The thermography on the left-hand side, when we talk about SADE, the insulation, exterior insulation, but sometimes we have horizontal insulation as well. This is part of a balcony that is a bedroom, in fact. We identified this, and it allowed us to understand the weaknesses that we have to focus on. Additionally, we have another test of execution of the construction work that we do, like SATE. And what we did here is check the execution and implementation of the different insulation layers, or also the polyethylene that we include. We perforate the facade and we think that everything is correctly built, but sometimes, like we see on the right-hand side, some areas are not done properly, insulated properly. So with these tests, where we open a hole and evaluate, we can detect the problems. All of this data is evaluated and will be evaluated in a different tender for the evaluation of the models and monitoring of the results. And I want to spend a little bit of time discussing this slide. We spoke about the CO2 concentration previously. These graphs are from January 2019, and back then AVRA was already monitoring the CO2 emissions of their public housing stock, because we are creating very insulated buildings. And we wanted to include air renovation systems. Okay. If we include a very good window in an area where before there was a very bad window, everything becomes very airtight. So it's very important to understand how ventilation is going to help. This is the graph. Is a whole day. Bottom right is electricity consumption, how it peaks. The top right is the blue temperature. Is the blue line, the dark one is the temperature of the living room, and the bottom one is the bedroom, and how the temperature increases in the living room to 20 degrees. And what happens to CO2, which is on the left-hand side graph? It peaks to more 3 ppms when the technical regulations point to that air quality above 2 ppm is problematic for the user's health. So the CO2 concentration goes way above what it should do when there is no ventilation. So this type of test aims at understanding what we can't see as technicians. And of course I would like to commend the work of my colleagues, because this requires a lot of dedication, because not only are you coordinating and managing the construction works, but also you coordinate all of these tests to understand how you're progressing. And this is all from my part. Thank you very much.
Y ahora damos paso al bloque de comunicaciones.
And now we move on to the sub-block of scientific presentations. The first researcher is Maria López Gómez from the University of Granada. The title of her presentation is The Study of the Feasibility of Incorporating Volcanic Ash from La Palma and Clay Soil for the Production of Bricks. Maria López is a wonderful researcher. She's a little over 20, and she was the first to come up here because she wanted to see where the timer was. And she said to me that it's the first time she's going to give a presentation in public. And I told her, don't worry, you'll do a wonderful job. And it's a very interesting title. So I wish you the best of luck. And let's welcome her with a warm round of applause. Thank you. Good morning. First and foremost, I'd like to thank the organisers for giving me the opportunity to participate in this conference. I'm a PhD student after carrying out a soil science degree at University of Granada, and I'm accompanied by Giuseppe Coltrone, Ignacio Valverde Palacios and Francisco José Martín Peinado, and we've studied the feasibility of incorporating volcanic ash from La Palma volcano into clay soil for the production of bricks. So how did the idea come about? Well, during a volcanic eruption, a huge volume of lava and pyroclasts is produced. In the case of the Tojalgaite volcano in La Palma, this was no exception. The eruption began in September 2021 and lasted 85 days. During that period, approximately 45 million cubic meters of ash and tephra were produced. These materials cause damage to infrastructures. They can also cause airports to close, and they're harmful for human health, giving rise to or aggravating respiratory problems, causing irritation to the eyes and the skin. There's also no clear regulation governing the collection and storage of these materials and their recycling, so we felt it would be worthwhile incorporating this into our study. We wanted to study the viability of incorporating volcanic ash from La Palma of two different sizes as an additive for brick production. In this picture you can just see a spoiler of the final results of this study, which shows the brick produced with volcanic ash cooked at three different temperatures, 800, 950 and 1000 degrees centigrade. If you see that the corners are rather worn, it's not because that's the way they came out of the oven, but it's because we already have carried out some biological and chemical studies on the samples obtained. As regards the methodology applied, we studied the chemical composition using XF, RF and mineralogical composition using XRD technology. For both the lapilli fino and also the volcanic ash. Ash granulometric separation was performed using screening for 0.6 millimeters and thick meshes of 0.6 to 2 millimeters. We also studied the granulometry of the fine ash and the clay soil using laser technology. But for the clay soil, we had some problems because the clay soil provided a excessively low percentage, and so we had to apply the Robinson pipette to obtain more convincing results. In addition, we also studied the different Attenberg limits to measure plasticity for both clay soil and without thick and fine volcanic ash. The results of the fluorescent X-ray tests showed that the clay soil presented a loss due to which was much greater than the volcanic ash, and this is largely due to the presence of carbonates, and during this process it loses CO2. This can also give rise to dehydration of the lapilli fino, of the pyroclasts, and there's also a higher content of sodium, potassium, iron, magnesium due to different mineralogical differences. The result of X-ray diffraction revealed that the clay soil presented phyllosilicates such as illite, paragonite, chlorite, kaolinite and smectite, quartz, carbonates, gypsum and plagioclase. And X-ray diffraction of the volcanic ash presented olivine, augite, hornblende and magnetite. We can also see that the diffractogram for volcanic ash produced some noise, and this was due to the presence of glass. As regards the results of granulometry tests, volcanic ash granulometry measured using the clay soil granulometry measured using the Robinson pipette was presented in a Winkler graph, and we calculated the granulometry that would be attained by adding 10, 20 or 30% additive of volcanic ash. When clay soil was presented without the additive and 15% of volcanic ash, it would be in, let's say, field 2, which would correspond to perforated bricks. Therefore, these materials would be good for producing perforated bricks. And when 20 or 30% volcanic ash is added, then this would fall within field 1, which would correspond to solid bricks. I'd also like to highlight that when fine volcanic ash was used, which appears here in red, the results were towards the right in red, and this is because the percentages were between 2 and 20 micra. In terms of the Attenberg results, these are presented in a Ben and Hailey diagram, and we can observe we can see that when plasticity, the started plasticity was compared with the addition of volcanic ash to the clay soil, this shows that this could be used, however, when 10 or 20% volcanic ash is added, this would be unsuitable and therefore would fall outside of this range. Therefore, the use of volcanic ash makes them unsuitable for extrusion. Conclusions. The addition of volcanic ash to clay soil of Visnar in percentages of 10, 20 or 30% allows us to produce solid bricks, although it limits the use of an extruder and prevents the production of perforated bricks for 20-30% additive. For this reason, the addition of these percentages of volcanic ash to clay soil in Visnar is suitable for the production of craft-style bricks. I hope that you found the presentation interesting, and thank you for your attention.
Sí, lo que pasa es que cuando nos giramos, pues no llega ni el audio. Pero bien, pero yo no te he escuchado muy bien. Enhorabuena, María. Bueno. Estoy cambiando yo aquí. La investigación, la ciencia tiene futuro. Lo acabamos de comprobar.
Research and science have a future. We have just seen that. Just want to point out that we need to speak close to the mics because the streaming and the interpretation require that you speak close to the microphone. So please, when you're doing your presentations, have a look. Please look at the monitor that you have in front of you and focus on the microphone. Thank you. Having said that, we shall continue with the next presentation, scientific presentation. The researcher is Clara Parra Fernandez from the University of Granada, and her presentation is entitled The Properties of Natural Hydraulic Lime as a Sustainable Building Material. Please, a round of applause. Thank you. And she's also very young. First of all, I would like to thank you all for the opportunity to speak to you, and I hope that you find this presentation interesting when it works. I'm going to talk about the properties of natural hydraulic lime as a material that is usable for sustainable building. Lime is part of our society in many sectors as part of our environmental activities, water treatment plants, processing of food, and in agriculture. The global production of lime is 430 megatons in 2019. Only 18% were used in 2018 for construction works. What is important is the use of lime for the improvement of the properties of resistance to, and it is also helps for the for the use in asphalt. In the construction materials, lime can be used for aerated blocks of concrete with thermal and acoustic properties, and as additive to cement, mortar, to reduce the sulfate problems, and the dolomite limes. The aerial limes and hydraulic property limes tend to be used for mortar, for outside and inside use, for new construction and rehabilitation of heritage construction works. The hydraulic lime as a construction material dates back to the Greeks and Romans, and what they did was use ceramic dust or volcanic ash to transfer these hydraulic properties to their construction materials. In the 18th century, when this material became reused, the mechanism by which they inferred hydraulic properties to it was through the calcination of clay rocks. And this allowed the material to work hydraulically, which is the difference between the hydraulic lime and the air lime, because they both react to water or to air. And for construction and building limes, we have two types, the aerial or the air limes and the hydraulic limes. There are other hydraulic limes, which are the formulated ones, and the hydraulic ones. I'm going to talk about the benefits of this material in terms of its production and its hydraulic properties. For its production, as for the Portland cement, we use carbonation and CO2, and if we look at this chart, we see that NHL require less energy for production and produce to capture CO2 and balance its production, because it is used for several processes. This also happens in OPC, although it has less carbonation because it has more hydraulic phases. The silicates that I spoke about before imply that the Portland cement requires the treatment of the material itself that the limes does not have, because you don't need to add anything to them. With regards to the natural NHL properties and hydraulic properties, the natural lime is more porous, and has more pores and is more porous, and so that means that mortar is more breathable and permeable. And what would this imply when we use it for construction? Better air quality and higher durability of the materials that are used in construction. The main reason of why it is used widely for architectural heritage, because old materials are in disrepair and they require mending with something that is similar. I would also like to mention that natural lime is not a material that absorbs a lot of water and is not rigid. It is it's a material that has plasticity, so it can adapt well. I would also like to mention that if these properties were not enough, because like any material, it has its setbacks, there are several studies that have analyzed the addition of different products, some products of other industrial activities like different fibers, ashes, and this in combination with the lime mortar is improved. And I also wanted to talk about the mortar together with cáñamo. And they have low biodeterioration. Natural limes go through a process which requires less energy, and it contributes to the CO2 positive balance, and they can be used together with hemp. Its physical and hydraulic properties means that we can create more permeable lime mortar, which have an impact on the durability and quality of the buildings that it is added to. And finally, although it has difficulties in its setting and it has a few mechanic resistances, currently the study of the use of this material is in vogue, and there is research that is helping to improve the qualities that this material has. And finally, I would like to point to the project of optimization of this project where I'm doing my PhD, and I hope that you have enjoyed my presentation.
Gracias, Clara.
Thank you, Clara. Another very interesting subject, another scientific presentation now will be presented by Marcos Lanzón, researcher from the Polytechnic University of Cartagena. The title of his presentation is Earth Materials with High Resistance to Water and Acid Rain.
Sí, ahora lo saco yo. Como soy el último de la serie, no voy a molestar a nadie, ¿no? Vale, gracias. Hola, buenos días.
Good morning. Well, as you can see, the title of my presentation is related to previously published results in a scientific journal. I've tried to condense the most relevant data for the conference, and I will talk about the resistance that earth materials can offer in atypical conditions to which they may subject on some occasions, such as water or acid rain. Well, I think that we all know in this forum the properties of these materials. Perhaps what's most interesting for us at present, I was interested at the discrepancy that exists between the EU directives and the way in which the construction sector has a tendency to implement these actions. For example, under Mission 1, these will respond to adaptation to climate change. And these would be sustainable options with respect to Mission 4, which has been established as an attempt to create or develop cities that are sustainable from a climate perspective, or climate neutral cities from a CO2 perspective between now and 2030. Given these important objectives established at EU level, it's evident that we, as Western societies, could propose making more intense use of these materials. But in addition to this severe problem, there's an even more serious problem. And in Africa, according to all statistics and international fora, which have been echoed in different publications worldwide, it's forecast that Africa's population will double by the year 2050. This means that they will increase from 1.2 billion to 2.5 billion people, and we can imagine what the repercussion this demographic expansion will have in terms of the consumption of steel, iron, cement and concrete, and the impact this will have at a planetary level. Nevertheless, it's also true, and it's worthwhile highlighting this, that those materials are accompanied by additional difficulties. And I'm sure that you are all familiar with this. This may occur in the case of rammed earth, for example, walls. These are not entirely resistant. They have a limited durability. For example, if the earth material is attacked by any adverse phenomenon. Well, the objective of this study was to try to look at ways in which the durability of these materials could be improved through the introduction of surface covering, but also additives that would be dispersed throughout the entire matrix of the material, or the cement-based material. When I say cement-based, we shouldn't take that literally, so that it's able to, let's say, perform more homogeneously and in a durable manner over time. The experiments were basically planned, and I'm summarizing enormously. There were more trials, but basically they focused more on durability. This slide shows the structure of the stress test that we used. In this case, we used this type of bivalent metal. Could be zinc, copper, magnesium, or calcium. And different doses were tested, which are very low. And even with low doses, such as 2%, we can see that relevant results were obtained at durability level. Different trials were performed, but the most important ones within the context of this study included capillarity and permeability studies, immersion durability studies, rain and acid rain simulation tests, using H2O and a mix of H2, SW4 and HCl. And we can also see this type of device which was used, which would, let's say, drop the chemical on the surface of the different materials. And on a complementary basis, SEM microscopy was performed for the inspection of the surface of the specimens. As we can see from the results, the capillarity results or levels were reduced substantially, particularly given the range of doses that was considered. This is a low dose range. If we compare the permeability gradients or capillarity gradients, let's start with capillarity. We can see that the gradients or slopes are similar to the strictest requirement for different types of cements, the types of cements that are used with these classifications under the EN 9981 classification. A minimum classification required is W1 or W2. This means that these type of earthy materials could be used on construction envelopes if they would comply with these construction formulae in accordance with CE markings. And as we can see on the permeability graph, regarding the dose of additive, we were not able to achieve capillarity at a dose of 0% because of the damage that was caused on the permeability surface. Therefore, these permeability parameters were obtained because we observed a very strong correlation of almost 100% with an exponential decrease in permeability. And we studied this value theoretically, but we didn't study this at study level. And as I said before, this was largely due to the fact that we didn't have any additive in this case. As regards the immersion experiments in water and in acidic water, this corroborated the protective property of these additives. As we observed, there was a sharp drop in the alteration or the matrix with these additives, specifically with this one. And there was also a difference between hydrochloric acid and sulfuric acid. We observed full dissolution. However, sulfuric acid, which is more similar to the acid that's present in acid rain, has a dual function. On the past, it acts as a solubilizer and it disaggregates the material, but it also provides a protective property to make the material more resistant to external attacks. That's the reason for these differences. And as regards the different other tests that were carried out to determine the alteration, we wanted to look at the results that obtained due to rain and due to acid rain. For the controls, we have the aggression levels. We can see that the tests are less aggressive. It's simply a question of continually dropping this type of mixture on the surface. As we can see, the alterations were substantial, but at the end, in the case of 25 or 30%, but we also observed a significant decrease in alterations in both cases, in both scenarios. as the additive dose was increased, to the extent that we were practically unable to distinguish in terms of weight whether there'd been an actual alteration of the samples or not, and also a degradation of the plaster on the surface. We didn't present this, but we also obtained the following results with drops with high contact angles, 2%. So the contact angles were close to 160 degrees. And finally, as we can see in the microscopic images here, we can observe here that these crystalline structures or matrices appeared here under the microscope. The attacks were more significant when the additive dose was lower, as we can see here in these second images, 0.5% or 2% in zinc extract, where the crystalline structure was more reduced. And at the top, we can also see an example of the samples before they were attacked. And I'm going to read the conclusions very, very quickly. We observed a very significant improvement in the performance level at the level of permeability and capillarity, which is even greater than that offered by certain cement-based materials that are currently on the market. Additives, in the case of immersion tests, also alteration by immersion also was clearly reduced, and with an improved level of protection with the additive. Thank you very much for your attention. That's
Thank you very much, Marcos. And now the next scientific presentation from David Grisaleña, Housing and Land Management in the Basque Country, improving the sustainability of the rented public social housing stock in the Basque Autonomous Community by means of renewable electrification. Welcome, sir. Good morning, and thank you for allowing me to speak to you all today. It is very focused on social housing. As you see, the title, Improving the Sustainability of Rented Public Social Housing, is very long. It basically focuses on the electrification of our social housing construction 100%. So all of our social housing is fully electrical. This all electrical model comes from a long reflection and understanding of the experience of social housing production. We also include the input of 2 European projects, the BEMES, where we talked about solar energy production and the intelligent analysis of all of this. Also, the energy analysis bearing in mind the users. And they were housing management models that integrated energy, and another project that wanted to make social housing more accessible in terms of price. So we developed a methodology that allowed us to create more accessible social housing. We had a series of external inputs like the Green Deal, the Energy Performance of Buildings Directive, the Directive for Buildings of the Basque Government, and the habitability framework of the Basque Country. We created an element within our strategic plan where we wanted to continue applying energy efficiency for housing. The objectives was creating a housing stock of social housing that was near zero consumption, that were renewable, that allowed us to decarbonize the use of the housing, reduction of costs, having a higher life cycle, and reduce energy dependency and less energy consumption. We want more efficient buildings. And Valentin especially talked about the circularity and sustainability. We need buildings that are adapted to the new paradigm that is required by this planet. Buildings have to be resilient, adaptable, and electrification helps towards this goal. How have we done this? Technically, there are many ways of doing so. Like I said, our aim is sustainability and stepping away from gas. So the best way is electrify consumption, doing so through sophisticated ways, through heat pumps, centralized heat pumps that supply the whole of the building. There can be only heat pumps for water heating, and you can have simpler methodologies like electric heating devices. I'm an engineer. Most of you are architects, and your training is different, but when an engineer is told that you're going to use an electric heat radiator, they get scared, they think about the Yule effect, but this is innovation for social housing. And social housing has a series of elements, which means that we have to annoy the user the least possible. It has to be simple, it has to be robust, it has to be durable. So an electric radiator for heating is a good way of using technology. Of course, this technology can be improved so that they can store energy and store it during night and use it during the day, for instance, and release it during the day. As you see, solutions are there. We have electrical water heaters. They're not complex solutions, but they help to find sustainability. We worked within the Basque autonomous region, and you have several examples here. I have included them mainly so that when you have a look at this presentation, you can analyze the different types of buildings that we have acted upon and different solutions that we have implemented with regards to electrification. The heating electrical demand in these buildings is very low because the buildings are already very efficient. So this additional energy that is renewable can be done very simply to solve the needs. We hope to have, of course, social impacts because this is social housing. We want to democratize the production of energy and move away from depending from the great electricity providers so that people can have the power to choose how they want to manage their appliances and how they want to be more sustainable. And we also open the door to the creation of energy communities or cooperatives, and we also want to reduce the energy dependency from third parties. There's, of course, the economic impact. We are a public housing construction company and real estate promoters, so we need to have higher life cycles and less global costs, and we want to simplify the construction costs, and we want to level the ground for new ways of hiring and of obtaining energy, and of course new ways of sharing out the excess electricity or of storing it. Our environmental impact has meant that we have reduced our CO2 by 30%. I wanted to include a percentage. This is a theoretical calculation that we have calculated internally, but we believe that the tendency is the reduction of at least 30%. And we are already in the building phase of all of these housing stocks, so we will be able to finalize these calculations. Other benefits: simplify and make flexible the architectural designs, reduce our construction costs, reduce the using of utility costs for the people that live in it, reduce the maintenance also. It simplifies the management of getting electricity and water for your house, simplifies the lack of payment procedures. And I have 30 seconds left. I wanted to add that, as you saw at the beginning, I represent the innovation and sustainability area of the housing and land management of the Basque Country. I wanted to give you the opportunity of participate together in European projects and other initiatives and creating partnerships. We are very good partners because we have very good examples in different housing stocks that we manage, and we want to be very innovative. So thank you very much for your attention.
Muchísimas gracias, David. Y ahora la...
Thank you, David. And now the next scientific presentation, I would like to ask Ángel Luis Benito Pérez and Agustín Castillo to come up to the stage from Granada City Council. The title of the presentation is Circular Economy and Construction Based on Local Governments. Good morning. My name is Agustín Castillo, and I'm accompanied by my colleague Ángel Luis. And this morning we're going to present results of a research project that was promoted by the European Union, the URGE Circular Building Cities project, which forms part of the URBACT 3 ERDF programme. The project involved 9 European cities, including the city of Granada, and it was carried out between 2019 and 2022. We've been fortunate to lead the local action group in the city of Granada, and we would like to present the results of the study. At the meeting of the 9 cities, the aim that we all sought was to ensure that we were honest about the real situation regarding construction in our respective cities, and also the circular economy in those 9 cities and 9 states in the European Union. And we really had to, let's say, empty our minds, put to one side any urban legends or myths, and also put to one side best practices in construction and try to be realistic about the situation to ensure that we applied a real focus on circular economy and construction in these 9 cities. The map shows the city's location. The lead city was Utrecht, but there were others such as Munich in Germany, West in Portugal, Copenhagen, Denmark, Riga. Each city had a different approach. So at the beginning, we had to examine the reality in each city, looking at examples of success stories and failures, and try to understand why some things worked and others didn't. We tried to identify the social and cultural or economic aspects that were important and focus on not just the economic aspects, but also we tried to look at what was working well and effectively in the different member states. And we also tried to use a transnational approach. We had to provide a European solution for engineering construction. And obviously that approach would be richer if we were able to incorporate the perspectives of 9 different cities or cultures from the European Union. So, based on that premise, we examined the strengths of each city in the project. And at Granada, we felt that we could contribute a lot of know-how about historical heritage, how we could make a city that is strictly regulated by the regulations on its historical heritage. What type of contribution could it make to the circular economy? Then you can see the different approaches for each city. Utrecht was highly specialized in urban development. Copenhagen had an excellent public works system. Kavala in Greece were experts in regulations. They provide guidance and counselling to the Greek government on specific regulations. Maribor, well, they are specialised in industry collaboration. Munich, they are experts in recycling technology, with some of the most interesting studies having been performed there. In the western municipality outside of Lisbon, they have extensive experience in waste management. Plato was known for its municipal global strategy, and Riga, the capital of Lithuania, on energy and facilities. So, as regards the main results, my colleague is going to present the results. A local action group was set up. There you can see the members of the group here on the slide. And all of the stakeholders that we contacted were interested in participating. And he's going to present the main results of the study. Well, the first result of the project was being able to get all of the stakeholders around the same table: professional organizations, clusters, and also public administrations, clusters that are highly committed to the circular economy and sustainability. We were also accompanied by companies such as in El Soto, which aggregate recycling company, and they explained how they were able to sell their products, and also municipal management entities such as Granada Eco Park Consortium, to which we belong, which is responsible for the management of domestic waste. So the barriers to this project were the ones that were indicated here on the slide. Again, we wanted this project to be participative and transnational, and these barriers were very similar to those in the other European cities. Firstly, a lack of specialization. Well, as you know, it's a sector which is closely linked to SMEs and self-employed workers, and there's a severe lack of specialization in the recycling sector. We did have some interesting presentations yesterday by people that do specialize in this, but it's not the norm. There was also an absence of local debate. When the project began, the concept of circular economy was limited to university circles, but it wasn't really discussed much outside of those circles. There was also a need for value of good practices, and also the lack of a market for secondary raw materials. There was also a need for local initiatives. Recycling companies, projects that we would like to incorporate, such as Santadella. And they were willing to act as a shop window for the presentation of the project. And they encouraged us to, they stated that, for example, it was important to listen to our lead and to our recommendations very, very quickly. The proposed measures focused on the development or creation of a local committee as an extension of the local action group, dissemination and awareness raising activities to ensure that all stakeholders will participate for the benefits of society, the promotion of training, a local directory in construction for the benefits of all. And as regards the competencies specified by the City Council, bids regarding works, projects, building tax breaks, maintenance of own buildings, flow mapping, local office of rehabilitation, circular communities. These are the actions that were performed. I'm going through this very quickly, says the gentleman. There were also a series of measures that were implemented. We presented the plan that was approved on the 30th of June. Therefore, we're still in the embryo stage. Various conferences have been organised, as well as open days at schools, and we also have specific ordinances. This is a pioneering ordinance, although the scientific committee prefers not to use that term unique or pioneering, because we carried out a study. The ordinance came into force in 2023. It allows for a reduction of almost 75% in the cost of a license, in line with these percentages here in the table on the right, for documentation, which can also serve as a later indicator which will give us an idea of how the circular economy is evolving in relation to the construction sector. And this is a technical tool, and this is something that can be used when presenting projects. And this was referred to actually yesterday by Ignacio Perinado. And this was something that was already discussed about 15 years ago anyway. I know that in each city there are different systems. I know that one of our colleagues this morning talked about the paleoclimate. I'm really interested in local ordinances. And I watch films like Matrix, and I love all these type of things. And I felt that this was the simplest way in which we could enzymatically encourage private developers and to provide a little colour to the project in order to inform them of the potential benefits that they'll obtain. In terms of the conclusions, well, it serves as an exemplary, highlights the exemplary role of the City Council. It will serve as a municipal shop window for the project and for the benefits of these type of initiatives. It has to be done in collaboration with yourselves and with other businesses. And I would like to leave you with this phrase: you don't have to do any of this, but survival is not mandatory. Thank you very much for your attendance. Thank you very much, Angel and Agustin. So with that, we wrap up this block on scientific presentations with Madeleine Martelo from the University of Seville. The title of her presentation is Combining Indicators for the Assessment of the Life Cycle of Buildings, the Predice tool.
Bienvenida, Madeleine.
Madeleine. Good morning, and thank you for the invitation and allowing me to talk about the work that our research group has been carrying out in the University of Seville. Especially, our team is made up by me, by Cristina Ribeiro, Alejandro Martínez, Desiree Alba, and Jaime Solís. What have we focused on? We are technical architectural school professionals. We focus on the control of projects and how all of that information that we have allows us to evaluate other aspects aside, as well as economic control, like evaluate the social and environmental aspects. With regards to what I'm going to present to you today, we do an analysis of the life cycle of buildings. The building starts off with a design, has a very long life cycle in terms of housing. They tend to have about a 100-year lifespan. And the initial decisions really affect and have an economic, social, and environmental impact in the future. In our research group, we analyze the three dimensions of sustainability: the economic, social, and environmental aspects from the point of view of the project and execution of social projects. We also evaluate work risks as well. We carry out our work using three indicators, analyzing the life cycle indicators. We don't use all of them, but we choose three that have a simpler message and that can be more understood by the general public. Environmental footprints, carbon footprint, and hydro footprint. And to carry out the resource inventory that are used within any project, we use the construction budgets. And everything is within those budgets. And from that information, we can analyze the environmental or social impact of the project. With regards to our project in Andalusia, we use the systematic classification structure of the construction works, and from that hierarchical structure, we provide to each of the basic lines of the budget their economic and social and environmental impact. So in this tree structure, we have managed to evaluate the 7 basic elements that are included, and we can redefine budgets. So in order to analyze for the future, we use the definition of renovation and rehabilitation, building and urbanization projects and indicators. And so we do this, once we've defined the construction unit, we can have a list of the resources that we want to evaluate. We have an example here of one of the case studies, and our tool allows us to determine in each of the phases of the life cycle, analyze how many materials have been used, the machinery hours, how many workforce hours were required for each phase, and we also evaluate the building waste generated, materials as well as packaging, and indicators like the used energy, the carbon, environmental and water footprint. Some construction units control the impact of the use of water, and others control energy consumption. All of this, once having evaluated all of the construction costs, has resulted in a tool called Predis, which is an IT tool, and it analyzes a budget in PS3 budget. This tool analyzes it, and it uses the codes from the construction codes of Andalusia, and it evaluates the economic and environmental impact. In this particular case, we have the hierarchical structure of our information. We have the red boxes provide the amount of waste that each of these units produce, and the blue arrow provides the environmental impact. Once we have created our budget, we include averages and prices and information, and this generates results. It identifies the 5 construction units that control each of the impacts: economic, environmental, social, and so on. And with each of these evaluations and analysis, we evaluate the economic impact to be able to understand the information per constructed square meter, and we can compare the footprints of one project versus another. If we have evaluated social housing, or we evaluate luxury apartments, we see that social housing versus luxury housing has 4 times as much environmental impact. So we can understand where our resources are going, and where emissions are generated, and where waste is generated. The result is an Excel spreadsheet where all of the units are evaluated within our project. They have the description with regards to the Andalusian construction list, and the evaluation of each of the construction units in terms of the indicators. We conclude with this, and I always close with this, and our aim is to minimize costs, which really aims and is the result of sustainability. We have to reduce environmental, social, and waste impacts that we produce. And we also want to bear in mind the impact that it has on the health and safety of workers. And thank you very much for your time. Thank you very much, Madeleine. Now we're going to have a coffee break. With regards to our carbon footprint, please register the QR, because at the end of our conferences we're going to support the environment. I also invite you to have a look at the posters of the scientific presentations which are outside. Thank you very much, and enjoy your coffee. Please respect timekeeping.
Tras esta pequeña pausa para...
Okay, after the short coffee break, and an opportunity to chat and get to know one another a little better and exchange ideas regarding our experiences and projects, and also have a look at the scientific posters that are just outside the auditorium. We'll continue with this block of the international conference, and we'll now move on to some guest speakers. The first speaker is Ana Sánchez Ostif. She is a professor at Navarre University. She leads the Xavier Arquitectura Research Group, Environmental Sustainability, Housing, Industrialization and Architecture. Her research fields focus on eco-design of industrialized and sustainable enclosures, energy sustainable renewal of buildings and neighborhoods, residential and socio-economic vulnerability, and the quantification of sustainable architecture. She's published articles on these topics as well as books in prestigious publications. She's been a visiting researcher at international universities, and for 27 years she's combined her teaching and research activities with her work at her own architecture and design firm. The title of her presentation is "Are Our Homes Ready for Climate Change?" Well, undoubtedly an extremely interesting subject. Anna, a round of applause.
Gracias.
Thank you. Well, thank you for inviting me to participate in this forum. It's extremely interesting. An opportunity for all of us to exchange experiences. As was said, the title of my presentation is "Are Our Homes Ready for Climate Change?" I would like to introduce this question based on current forecasts or predictions which indicate that the periods of heat will be longer and longer, that heat waves will be more frequent and more intense, and to a certain extent the period 2013-22 will appear in the ranking of the hottest periods in the recent decades. You'll remember 2003 and how hot it was back then. So let's see what happens this summer. And we can also say that we make enormous efforts to rehabilitate buildings to bring them into line with existing standards. We have enormous experience in rehabilitation of buildings and also new constructions. We are building... What's going on with the presentation? We're constructing new buildings in accordance with standards requiring airtight, highly thermal insulated buildings, and those comply with the technical code for the 1970 to 2000 time series Azrael, corresponding to the meteorological year from 1980 to 2010. And nevertheless, we're talking about the period 2013 to 2022 as the hottest in recent decades. Therefore, the measures that are being implemented are aimed at how we can reduce the consumption of energy for heating. However, these measures that are being implemented are also useful in the summer, but I would say that they're insufficient to avoid overheating of our homes. I'd like to try to respond to this question through a research project that we carried out called Klima Ready. And the Klima Ready project tries to determine whether our homes are ready for climate change and the adaptation of Spanish homes to climate change. It's financed by the ministry and is being developed by the University of Navarre in collaboration with a research team at the University of Seville, Rafael Suárez, Rocío Escardón, Ángel Luis León, some of the research team members. And the aim is to assess the current status of homes in Spain and their adaptation for climate change, incorporating passive measures for the rehabilitation of buildings with a view to minimizing overheating risks with minimum energy demand. The phases of this project consisted in defining climate zones, typologies, surveys among users in Pamplona and Seville, rehabilitation of buildings in Pamplona and Seville, simulations, and the presentation of the results via GIS in order to determine what their level of adaptation is. the first step considered in defining the typology of the constructive elements and techniques, because we have to try to adapt these properties accordingly. We can also present this in GIS-based maps, where we can also extrapolate the results regarding overheating. I'm now going to touch very briefly upon the survey, monitoring and simulation phases in order to respond, if I can, to that question. In the case of the surveys, well, surveys were carried out in Pamplona and Seville. These are general surveys, as we define them, during the summer. Panel-type surveys were carried out during heat waves in Pamplona and Seville. And the aim of these surveys was to characterize, or let's say identify the characteristics of these buildings in accordance with the thermal sensations and response of their users, and also determine user behavior, which has an enormous influence on overheating. Just to give you some snapshots, because it's very difficult for us to present all of the data today, we can say that 41% of the users believe that they're unable to easily control temperature within their homes during the day. And at night, they are less likely to improve the thermal conditions of their homes. Larger homes may be associated with lower risk of overheating because they may have spaces which present lower risks, more shaded areas, spaces where temperatures may be more amenable. And 94% of those surveyed use solar protection systems, but we can see that solar protection systems which give rise to a lower risk of overheating are those which combine, for example, awnings with fixed systems or outdoor systems with incorporating fixed elements, such as awnings or coverings. And those greater risk are those that only have interior protection or interior insulation, or don't have any form of solar protection. 14% of the users ventilate their properties independent or regardless of what the temperature is outside. If it's 40 degrees, they don't want to, it doesn't matter. They want to open their windows. Others don't ventilate their properties at night, particularly when it's cooler. Particularly in Pamplona, due to problems such as noise, due to traffic, or from people in the street, or because they don't have mosquito nets or screens, or because they're unable to open their windows and leave the window open in a fixed position. So there's a great deal to be improved in these aspects. As regards monitoring, well, the aims were to monitor homes in Seville and Pamplona to identify over 2 summers where there would be a likelihood of heat waves, how those homes would behave in normal hot conditions and during heat waves. In 2021 and 2022 there were heat waves, particularly in 2022, and what we did is select the homes according to their year of construction prior to 1980, after 1980, homes built in accordance with CDT standards or passive house standards in Pamplona, and in Seville before 1980 to 2006 and after 2006. And we always, for the same building, try to look at an apartment in an intermediary floor and also higher up or on the ground floor. I'm not going to talk to you about the properties in Seville because they will be the subject of an article that's just about to be finished, but I'd like to show you this graph. On the left we can see Pamplona, on the right Seville. In blue, the percentages of hours of overheating on the interior above the adaptative limit as we define it during one summer, a normal summer in this case. We're referring to 2022 here, but this would be during the summer months, days. And here, in these periods of heat, the interior section corresponds to interior results, 25% and 25%, that's how it's divided. And we can see that there is a significant difference between times when the temperature is or we have normal summer temperatures and heat waves. And in Pamplona, it's important to mention that most homes don't have air conditioning systems installed. What about Seville? Well, in Seville, there's a lot of air conditioning, and in normal summer conditions, people are using air conditioning more or less on a par, but obviously this also increases temperatures. Just to give you a snapshot of the differences that may exist between Seville and Pamplona, because I'm now going to move on to the results for monitoring in Pamplona. So if this occurs in Pamplona, what's going to happen in Seville? And And very shortly, in a couple of months, hopefully, we'll be able to present the results for Seville. As I said before, we monitored homes before CT79 with CT79 with the technical code and also with with buildings built in accordance with the Passive House standard. So what were the results of the monitoring process? Well, the factors or parameters which are more decisive when it comes to overheating normally arise during the construction phase. As regards CT79, this offers certain improvements, and they're significant, statistically speaking. We can see, for example, that, well, the results are not presented based on temperature, but rather hours of overheating on the interior of the home. Interior overheating hours. So we can see that with buildings built in accordance with CT79, the conditions are better with respect to earlier buildings. But CTE and CTM plus Passive House don't provide substantial improvements with respect to the previous homes. The homes built previously, actually they perform worse. We can see that overheating is higher here than during the period before CT79, and in those built in accordance with CT79 and Passive House, overheating is higher. In terms of orientation, window size, etc., we can say that the top floors overheat more than the intermediary floors. That orientation is not statistically significant. We can see that there's greater overheating on the south, southwest and southeast. So if a apartment is only facing in one direction, this will have an enormous impact on overheating negatively. If the windows do not have adequate solar protection systems, they will overheat more. And solar protection is more effective when there are fixed elements in addition to mobile elements. In other words, blinds will not protect entirely against overheating. If you have a blind or with a overhanging tiled roofing section or awning, well, this will help improve the overheating parameters. What are the aims in the case of energy simulation? Well, at urban scale, here we have to determine whether the microclimate or the urban environment has an impact on overheating of homes. Secondly, building scale, evaluate the risk of overheating. In this respect, we used the climate records for a standard climatological year, which would be the climate series of RAI, which is more modern than the technical code, and is therefore more adapted to the evolution that we've observed in recent years with regards to the increase in temperatures in the summer. And we did this with the climatological or weather records for 2022, bearing in mind that this was the hottest year in the last 10 years, and to a certain extent this would also give us an indication of what's going to happen in the future to determine any differential results. And clearly the aim here was to evaluate which construction elements have the greatest impact on overheating and which improvements have to be incorporated in new buildings and in rehabilitation procedures. As regards to methodology, well, we modelled building typologies, we compared different climate records. We also prepared microclimate records as well. We performed simulations for all typologies in the different orientations, properties with balconies, with and without solar protection, and with or without thermal envelope associated with the construction process. And the results were presented in IOHH terms, but it would also be good to present these in percentage of hours of overheating on the interior. And we linked all of these results to a GIS. We did this for the whole of Pamplona. I'm only going to show you the results for 2 districts this morning, because otherwise we'd need more time. The results for these 2 neighbourhoods or districts are conditioned by the situation of these. We have District N1, which was built in the period prior to the technical code of 79. The majority have a height of 25 metres with dark brick, compared with Mendijore, which is in the N2 district, built from 1990 to 2006. 5,684 properties with many green areas, and also an average density per home which is lower than that on the properties on the left. And we also looked at the climate records as well. We evaluated the readings of a climate record that took into account extreme temperature conditions such as those in 2022, and we also observed that with an average temperature there was an increase of 2.5 degrees with respect to the climate record used as a baseline. UL2 and also the maximum or minimum average temperatures with an increase of 3 degrees with respect to the baseline record. Therefore, in order to evaluate the scale and the influence that this urban environment has on home overheating, we generated or prepared certain specific microclimates for these specific districts using the Urban Weather Generator program, which was developed by MIT, which takes into account different parameters such as the following: building surface area with respect to the surface area of the district, facade surface area compared with the surface area of the district, the paving, the street characteristics, facades and roofing. It also takes into account the green surface area compared with the total surface area of the district, and we can see the difference between one district and the other, N1 and N2, and also as regards heat generation due to traffic, etc., etc. And using all of these parameters, we prepared 4 climate files, not just in ClimaReady, but also it forms part of a doctoral thesis that's being carried out within the scope of this project and which focuses specifically on this phase of the project. 4 microclimate files which contain the following: the baseline file with the microclimate in each district, and also the meteorological baseline register for 2022 with the microclimate for those 2 districts. What are the results? Well, if we were to now compare the baseline record or register with the baseline register for 2022, we can see that for the N1 district there was no overheating when compared with the baseline record, but there was overheating when we used the record for 2022. In the second district, we also see that there's no difference either with the baseline record, and with the 2022 record we also observe an overheating of 2.97 compared with 3.85 in the previous case. If within each of these districts we consider the homes which overheat, on the left the percentage was 35%, accounting for 3% IOH, and in N2 40% of the homes which exceeds 3% IOH. If we now take the microclimate records that we mentioned earlier, one clear conclusion is that if we look at the technical code records or the technical codes for the UL2, these would indicate that the properties in Pamplona don't overheat and nothing has to be done. However, during the summer everyone's dying from the heat. But if we take into account microclimate, well, in the UL2 records these would indicate that there's no overheating, that's obvious. Now I would just like to focus on 2022. So we have a baseline record with these conditions, these IOH conditions, and also the record presenting the microclimate figures. And we can see that interior temperatures will be higher if we use those climate records. But what this is really telling us is the percentage of hours of overheating in the interior of those homes. So based on the microclimate in these districts, this is intrinsically related to the baseline record, and it's significantly different, the difference between, statistically significant, the difference between these 2 values. In the case of N1, 95% of the homes or dwellings have an IOH above 3%, and in N2, 86% of dwellings have an IOH above 3%. As regards the construction parameters that bear the strongest influence, we validated the parameters that we extracted by monitoring. In other words, construction phase, orientation, height, number of windows, and the characteristics of those windows were significant. Those values indicate that those parameters were significant. And to a certain extent, on this GIS map, we can display the results that we obtained. At the top, you can see the results, the IOH results for a standard meteorological year from 1980 to 2010. We can see that everything is highlighted in blue, which is below 3%, whereas at the bottom we have the result, the IOH results for the climate record for 2022. And in this case we can see that overheating is 10 to 20 IOH. The results are presented for apartments and intermediary floors, and on the top floor Itiurana was built prior to the 79 technical code. The roofs don't have thermal insulation, so there's the difference here between this map and this one. In the top maps you can see these marked in blue, and we can see the IOH range here. In the case of Mediorri, we can see that there is a certain degree of thermal insulation in the roofs, so this shows that the top floor apartments overheat more than the intermediary dwellings. So what conclusions can be drawn? Or what conclusions would we present based on the work that's been done thus far? Well, first and foremost, it's not sufficient to design and make buildings face in accordance with the parameters necessary for the wind tunnel. These are not sufficient, and this has also been validated by or is confirmed by the bibliography. There are publications which indicate that well-insulated properties with a high level of air, or with a very high level of airtightness, if heat enters the building, those dwellings are unable to dissipate the heat. So we've got to find a way of preventing heat from penetrating the interior of a building. Secondly, it's important to evaluate overheating, not just simulating the building as an isolated entity, but rather simulating the urban environment, because it does bear an influence, as we saw with respect to the microclimate, because the results will be much higher in IOH terms if we were to compare this with not including that parameter. And of course, we will have to weigh up the risk of overheating, perform these simulations to identify the parameters that have the strongest influence. And finally, user behavior. We may be designing these buildings very well, but if users don't know how they have to use the building effectively, perhaps overheating levels will be higher than forecast. And finally, in terms of existing climate records, well, it's essential that we have these. And we'll just have to wait and see if 2023 is worse than the year before. It seems that summer started really early this year, and we do need to have climate records which will reflect these hot periods, which is something that has increased in the last 10 years. And the parameters that have the strongest influence on overheating are as follows. Dwellings located in older districts where buildings were built prior to the 79 technical code that are located on the top floors and which face south, west or southeast, or south, or just face in one direction, with hollow surface areas above 4 meters squared without solar protection systems that are adequate, are at greater risk of overheating than those that do not. However, we continue to build more or less the same as we've always done. So, and this is the final slide, one example, for example in this building, while we're monitoring all of these dwellings, it's a EZB building, EZNB building, in other words it's a almost zero consumption building. I know that in Seville people will use solar protection systems and they may spend a whole day in the dark. But we also have to consider about the way we work. If we're working at home, we cannot always be working at home with the blinds down. So solar protection systems shouldn't just be one thing or the other. Maybe we should develop awnings or blinds in a different way. So I would just like to show you one final thing. Although this dwelling faces in two directions, it is a dwelling that faces in two directions. These are the conditions in the winter. All of the results are within the comfort range, or the accepted comfort range, and in the summer all of the values are above 26 degrees. This indicates that we continue to design buildings and repeating processes for winter conditions, at least in our climate zone, and not in taking into account summer conditions. Thank you.
No pasa nada, vamos bien de tiempo y voy a lo mejor. Gracias. Gracias, Ana.
Thank you, Anna. And now we're going to continue with the next guest lecture by Rafael Suarez Medina. He's professor at the Advanced Technical School of Architecture, University of Seville. and he teaches architectural constructions 1. He developed his research in TEP 130 group, Architecture, Heritage and Sustainability, research carried out on acoustics, optics, light and energy. And he focuses on 2 fields, architectural acoustics in relation to the recovery and enhancement of cultural heritage of religious spaces, and environmental conditioning, a 2-fold focus on rehabilitation and heritage. He wants to link environmental and climate to architecture, and he is also focuses on energy rehabilitation, improving environmental quality and comfort conditions in the current building and housing stock. And he will talk to us about energy vulnerability indicators of Andalusia's social housing stock for the prioritization of refurbishment actions. Welcome to the stage, sir. First of all, I would like to thank the organization of this conference for having me invited to talk to you about the work that we are carrying out within our research group. I would like to summarize as much as possible what we have done recently. Almost 90% of the housing that we have for 2030 have already been built. And it's not something that happened recently, but as you see here, Bernardo Secchi already pointed to the fact, to this fact in an article in the magazine Casa Bellica, where he pointed to the fact that things had changed. And this was published in 1984. He said that the architectural debate with regards to cities had to be based on what already existed. In a sense, in architectural schools we have been educated in new construction, but our future work is going to be developed and focused in the periphery of cities and already built buildings that require improvement of the lifespan and the conditions that they offer. These buildings, generally built in the 1980s, do not comply with the needs that we currently have. However, we have, of course, mentioned this throughout this conference, but these actions that we have to bear in mind have to be contextualized within the current times, and there are 2 issues that we have to face. On the one hand, we see in this graph, which is a barcode graph, where we see the average temperature in the last century, and the last years correspond to the red lines, which predominates evidently. So there's an overheating which cannot be denied, and it's there. It has come. And we have to face the vulnerability situation that springs from climate change. We cannot leave behind either the social impact that this has. Social impact that during the pandemic made evident issues that were there but that we didn't really want to look at. And it really pertains to the fact that certain building typologies, schools, old people's homes and housing are spaces that couldn't really help in this new situation that we went through, because they weren't healthy to live in as much as we thought they were. Evidently, we have the Green Deal, which proposes neutralizing carbon emissions. We also have a new wave of renovation and rehabilitation of buildings. We have employment improvement and our life being improved. But this intensive renovation plan has to be considered in light of whether we are ready to face this urgent need, which is going to increase and it's going to be more intense. And when I say all and we, I mean the public administrations, which are going to have to devote considerable resources to this. I mean the technical staff that is going to have to carry out work that differs from the one that they do now, and we may have to be trained so that we can do so correctly. And I also mean with this we, the users, because users are key. We're doing many simulations and calculations. All of this is in vain if the user doesn't manage their house correctly. All goes out the window. So this part of the equation has to be considered. Users, unfortunately, are not very aware of the problems that they have and the need that they have to act regarding it. This is the project that we are finishing, Project Vulnera, whose objective is to identify the vulnerability levels through a quantitative analysis based on public databases which can be publicly consulted. And the aim is to allow decision-making for those who will be responsible for these rehabilitation and renovation processes. Vasco Peixoto yesterday pointed to the fact that indicators cannot only be related to the consumption regulations. People have decreased their consumption of energy because they do not have the money to pay for it, and this is detrimental to their comfort. So we have to work on comfort. So we placed two indicators, one regarding the building, which is pertaining to the evaluation of comfort with regards to energy demand, and another one that is linked to the user and the vulnerability linked to the level of income. And there we want to establish a vulnerability index. And we wanted to answer the following question: what is the degree of vulnerability, energy vulnerability of our house, and what is the priority that we need to bear in mind for the rehabilitation and renovation of the housing? We have gathered our data from the database of ABRA, the Agency of Renovation and Rehabilitation of Andalusia, housing of course, and it has 39,500 dwellings. And they have two types of buildings, lineal and linked buildings. That database has all of the Andalusian climatic areas, and most of the buildings were built between 1980s and 90s. Housing which doesn't really work energetically very well, with very high energy consumption in winter and very different living conditions in the summer, because, for instance, Granada is a sea area in the summer, but Cádiz is different because it's more temperate because of the sea. The installations of utilities for heating and cooling are installed in each of the houses. They generally have heat pumps and electrical systems. The first indicator was to evaluate demand, and our reference value, of course, we gathered the demand from the energy certifications, and the indicator that we chose were the recommended values for each climatic zone for the technical standards document H1. And this reference value was of 2019, but we don't think it's applicable as any longer. However, it evaluates the passive conditions of the building and utilities. There you see the graph by climatic area, and the red line is the average of the regions. It is a graph that shows that there's no that there is disparity in the results regarding the climatic area. And we can also understand from this that we are at a 1.5 to 2 vulnerability level, and the maximum is a 3. We also created an indicator linked to the income levels of users. Yet here the analysis cannot be a direct analysis because we can't access each of the houses, for instance, but we evaluated the census list and scales with regards to their income levels. The reference parameter is the average of the national income per consumption unit, bearing in mind that there is vulnerability if we go below 60%, and the lower limit being 40%, which are very severe poverty conditions, severe poverty conditions. Part of the housing stock would not have vulnerability, and we don't reach 7% of housing that are in extreme severe conditions. Another issue that we have to bear in mind before we analyze the actual indicators was something that we decided to do. We did a comparative analysis relating the indicator associated to the building to that of the indicator of the user, which allows us to quickly see double vulnerability conditions or situations which have to be borne in mind, and situations where that vulnerability is intensified or is higher. We don't only want to know whether this housing stock is vulnerable, but how vulnerable it is, which is perhaps even more important. The results by climatic area differ considerably. You see in the A3 area that there's a considerable percentage of housing that has energy vulnerability, but do not suffer income vulnerability, versus the B4 region, where there is 50 or 60%, which is doubly vulnerable energy and income vulnerability. Finally, what we did was bring together directly these results. We didn't decide to do an average of these indices because we didn't do a weighting because we would have to have done surveys. So what we did was add all of these levels, and here are the results. The whole of the housing stock is vulnerable from the point of view of the building energy consumptions or sustainability, and about 40% reached 1.52 vulnerability levels versus the 40% that went beyond 2 vulnerability level. We can highlight level 4, which is considerably higher in the A4 climatic area, and the percentage of energy vulnerability is very, very high, goes beyond 45%. And as a conclusion, I think it's important to summarize the main ideas. On the one hand, that doesn't require all of our study, but inadequate thermal comfort conditions due to low energy efficiency of housing, they're not adequate because this housing stock lack energy efficiency very evidently. They are houses that do not comply with the current comfort in housing that we require. So actions must be taken in terms of energy sustainability for these buildings. When we do this analysis, we also detected the relative importance of incorporating household income when we think about energy vulnerability, because the actions that have to be carried out in these buildings should not only be based on policies that are strictly devoted to energy aspects, but we must also prioritize actions incorporating the social component into the paradigm. So, bearing in mind social justice, we should try to incorporate actions linked to energy improvement and efficiency that helps improve the housing of lower income levels, where lower income levels housing really have less of a chance to face the energy problems. The indices that have been extracted from our work must be understood not in the sense of this level or that level, and also these indices are linked to a specific moment in time, but we believe that it is important in terms of the comparative value that it has when we can compare the situation of the different housing stocks. That comparative aspect allows us to activate the decision-making processes so that we can establish a priority list for the funding that is required to carry out these actions for building efficiency works. Our work is also aligned with issues that the Ministry of Transport, Mobility and Urban Development, where they want to analyze energy poverty, they want to analyze how this affects us, because energy poverty is very linked to consumption. And the vulnerability doesn't come from consumption because we can't, but vulnerability is the lack of comfort in this sense. It's very important to see things, to be able to visualize and generate databases that can be of open access, where we can add data and all of us can provide data. We are living in an era with lots of dispersed data and we're all duplicating work. So all of this information that can be grouped together would allow us in the future to face these problems, tackling them from different angles, from the public administrations, from the associations of property owners, the asset administrators, also bearing in mind user levels. This also allows us to work at different levels, so in neighborhoods and buildings and in specific houses. This is our first step, and now we're working on Reviva project, which is the natural continuation where we work in parametric models. And Rocío Scandone is going to explain that more in detail. And in this project, what we are going to do is try to provide optimization solutions to this energy efficiency problem. Thank you very much for your attention.
Muchísimas gracias, Rafael. Y ahora damos...
Thank you, Rafael. And now we move on to another block of communications, of scientific presentations in this case. I'd like to invite Javier Rey from the University of Malaga to come up onto the stage. The title of his presentation, Sustainability Indicators for a Renewable Energy System in a Dwelling Using ACL Tool, Life Cycle Analysis Tool.
Tú no eres Javier Rey, ¿eh?
Like Javier Rey. My name is Paula Esquivia, and I would like to apologize for Javier's absence. Unfortunately, due to a last-minute emergency, I'm standing in for him. I'm from the University of Granada. This presentation on sustainability indicators are within this block that we're working on relating to sustainability, circular economy and energy efficiency. This project presents a new concept. It offers a new perspective in relation to life cycle analysis. Generally, we're all accustomed to these life cycle analyses within the scope of construction in relation to construction products per se. Sometimes these life cycle analyses are evaluated from the perspective of product attainment or even in relation to the different phases of the life cycle or the different construction phases of the building. So rather than a maintenance focus, what we're going to do here in this study is turn things on their head a little bit and see what we can say when we approach this from the facility or installation perspective, how this life cycle analysis tool can have an impact on other parts of the dwelling or the building, precisely where there's more activity during the building's usage. I'm not telling you anything new, of course. If I say that buildings account for a large proportion or percentage of CO2 emissions worldwide, in the case of residential buildings, sometimes we're working with global values, and obviously we have to adapt, for example, these values to specific areas such as Southern Europe, where we have a hot temperature. 32% of that global figure corresponds to heating. Water heating, 13%. A lower percentage corresponds to cooling. And, for example, lighting, etc., etc. I'm also not telling you anything new. If we consider that the energy that's being consumed in Europe, 53% of that energy is imported energy. In other words, our energy dependence with respect to other countries or territories, well, there's the breakdown more or less. In terms of EU energy supply, it's almost 50-50. There's a high level of energy dependency. As Rafael mentioned earlier, this is why it's so important that we develop all of these initiatives and also encourage energy self-sufficiency and reduce energy dependency. That's the reason why all of these objectives have been set. All encompassed within EU directives on energy efficiency. But the European Green Deal does not only consider the question of energy efficiency, which is something that we may be more accustomed to working with and may have more present, but the Green Deal also touches upon aspects such as the circular economy, the reduction of materials and resources, in the specific case of construction, for the construction of buildings. Very recently, just a few months ago in fact, the circular economy law for Andalusia was approved. And one of the cornerstones regarding the way in which we should use these materials and resources in the construction process are used in the life cycle analysis. Through the approach that we propose, because we're all accustomed to talking about construction materials, but let's now look at what happens with systems. Systems rather disperse. They actually the arteries of a building. They allow different parts of the building to communicate with one another. And this is the reason why we are using the different phases that are outlined in the ISO 14040 standard. These different phases, actually 4 distinct phases. Firstly, goal and scope definition, then a life cycle inventory, which will give us an idea of the flow of materials, energy, water resources that take place within each of these phases. And the third phase consists of a life cycle impact assessment. This is done through, well, the standard actually establishes a series of categories in order to establish weightings of the impacts in each case. Therefore, this assessment of the impacts, resources and their association with energy will allow us to perform a final life cycle improvement assessment regarding the impact that this can have on the environment. And once we've completed the analysis of the impacts during the useful life of a building, then and only then will we be able to propose improvements. Within the context that's been defined by Europe for energy efficiency, and clearly we have to adapt this to the context of Spain, this is translated into a technical code, the idea being to promote the use of renewable energies to increase self-sufficiency. There's a great deal of debate regarding the use of certain renewable technologies to determine whether they're truly sustainable, because it's possible that many of the batteries that we obtain may be accompanied by high levels of intensity in energy terms. So for thermal solar energy, which is a mandatory aspect under the technical code, although there's different ways in which this can be approached, we performed a study to determine the environmental impact of a thermal solar installation via the use of solar panels. The case study in this case was an individual dwelling, 2 solar panels, the corresponding accumulator and also a boiler, a natural gas boiler, to complement the operation of the installation if necessary. And the first step considered in analysing that inventory of materials and energy resources. First, we analysed all of the components in the installation. Material resources, we looked at different material resources for the different collectors. The complementary elements. We developed that inventory in terms of the needs for those energy resources. Well, we also established the needs, the requirements, and exactly when we would need to use gas, natural gas for a boiler, in order to complement the solar energy requirements of the building. After completing that inventory, We correlated those values. We established those EDU values, the environmental load, the energy load values, and we would determine exactly what all of the parameters would be for the entire installation. And at the bottom, we carried out an estimate of the impact of each of those components, the accumulators, the boilers, and we can observe that the main or the highest levels of consumption corresponded to the consumption of natural gas during the usage phase. Fundamentally, the reserves of resources. And we can also observe that the solar panels and the piping presented higher consumption levels than the materials and the impact of material resources. In terms of analysing and evaluating those impacts, we can see that 85% of the building has an important impact in terms of the reduction of energy and material resources compared with 14% impact on human health. If we compare this renewable energy installation with that of a conventional installation, the investment in materials is much higher than a conventional installation. However, if we compare energy use, in this case natural gas, with the energy consumption of an installation working at 100%, operating at full capacity, then we will not observe those environmental impacts. Again, you will have access to a more detailed presentation and documentation. Since there are different technologies available to evaluate or assess the contribution of the different renewable energy sources, it's not just possible to consider the performance of the system. If we were to use this evaluation to determine its environmental impact, we could also not just use parameters such as performance, we could also associate this with the contribution that it makes. And we can incorporate more elements which will allow us to make a decision regarding whether we choose one technology or another.
Second scientific researcher, investigador Javier Sola Caraballo. We're going to hear about energy-saving potential of courtyard cooling in Andalusian social housing. Javier, I give you the floor. Good afternoon. I'm here to talk to you about this topic, developed together with Eduardo Diz, Carlos Rivera, and Carmen Galán. We are all part of the Department of Construction of the University of Seville. Patios or courtyards are architectonical elements that have been used for a long time, and research has previously proven that it's very good for mitigating the increase of temperatures. And our research is trying to highlight the capacity that these patios and courtyards have for energy saving. We have monitored the results in different patios all around Andalusia, and we have seen the effect on the microclimate that they create and on cooling. The better project is the one that we have been working, and we started out with the premise is that energy certification does not bear in mind the microclimate that is created in courtyards. So when they simulate the temperatures that the buildings would have, they never took in mind the courtyard. So from here, mathematics and engineers have developed a methodology to help with the Hull program. We were able to monitor the temperatures in cooling of the courtyards, and we managed to monitor the energy saving. Global warming is very evident, and in several areas we have seen an increase of it up to 7 degrees. And in Andalusia, by the end of the 21st century, we are going to suffer a 3-degree Celsius increase in temperature. Sustainable cities and buildings is part of the Sustainable Development Goals of the UN, which recognizes cities as one of the ways of mitigating climate change. Cities are, of course, subject to overheating. Regarding the difference in temperature between rural areas and city areas, this is very important to bear in mind. With regards to the methodology, 2 concepts are important within our research. The aspect ratio, the relationship between the height and the width of a courtyard, and then the thermal gap, which is the temperature outdoor and the temperature within the courtyard. In our research, we have carried out the study of 3 different patios and different geometry and different ratios. We have gathered data of exterior and internal temperatures, and we have used different temperatures for it. These are the cases that we have studied, and it's social housing, university, and a student's quarters. The differences in geometry allowed us to compare the aspects and measure the different aspect ratios. And they're all in Seville, which is a climatic zone before. We were able to access social housing through the collaboration of the Social Housing Rehabilitation Agency, AVRA. The methodology that we used was measuring temperature outside and inside, and we didn't want to only focus on the climatic records, which are of previous years. We have monitored the temperature at different heights as well within the patios, so that we could find out the stratified temperature of the patios. So the methodology that we used meant that we then went on to simulations. We did 3 simulations. The simulation A, where we changed the climatic records of the Leider-Kalner unified tools, and we applied it to the inside and the outside of the patios. And we weren't taking into consideration the shading. In the next consideration, we bore in mind the same temperatures, but we also bore in mind the shades, where it allowed us to find out the impact that shading had. And finally, in simulation C, we saw the different temperatures, the outside cooling and the inside cooling, which we monitored within the courtyard. And through the Leider-Kalner unified tool, it allowed us to understand the real temperatures that were actually taking place inside the courtyard. And here we see the results. And we see the thermal changes between external and internal temperatures. There's a difference of temperature between 10 to 14 degrees ranging within the different patios. When we see the simulation results, In each of the patios in simulation A, where we take into consideration the same temperatures for inside and outside, when we apply the parameter of shading and we apply the microclimate of inside the patio, the need for cooling is reduced. In the least favorable case, the reduction of need is 7%. And if we translate this into energy savings, we have up to 18% energy savings with regards to cooling needs, including the microclimate of the patio. This highlights the relationship existing between the aspect ratio of the patio and the energy saving potential. So the higher the aspect ratio in the patio, the higher the energy saving. Finally, and to conclude, this research wants to highlight the importance of vernacular architectonical aspects like courtyards, which mitigate extreme temperatures. And through the analysis of the microclimate of patios, we have seen a difference with regards to the exterior climate temperature of more than 10 degrees. So understanding these results within the energy consumption cases, we would manage to save up to 18%. This type of research means that we have a very important tool in terms of deciding construction designs, and this would increase energy efficiency, energy saving, and comfort of the user.
Gracias, Javier.
Thank you, Javier, and we'll now continue with another presentation. I'd like to ask Rocío Escandón from University of Seville to come up to the stage. She is the researcher who will give this presentation, and the title is Simulation Models for Metrics with the Evaluation of the Energy Vulnerability of the Social Housing Stock in Andalusia prior to the rehabilitation process. I'd like to thank the organisers for giving us the opportunity to present this project orally. It was carried out within the research group that I work in, together with my colleagues, as you can see named there on the screen. One of the main aims of rehabilitation plans in Andalusia is to improve the quality of life of the most vulnerable users. And if we look at the renovation rate of buildings, as mentioned in previous presentations, these improvements have to be implemented in existing buildings. And we all know that we have an obsolete residential park or housing stock. If we focus on social housing, we face these major challenges that have also been mentioned throughout the 2 days of the Congress. Firstly, energy poverty, and secondly, this evident climate change that we face. Hence the need to establish an order of priority in terms of the actions that we have to undertake, as Rafael mentioned. When we receive the funds, where should we start? Who are the most vulnerable? Which are the most vulnerable buildings? So in our opinion, in order to establish an order of priority, this methodology has to be based on a reliable characterization of the environmental performance of the existing social housing stock. In our opinion, we have to take one step forward in methodology terms to improve energy efficiency levels. The advantages that we have this information included within public databases. However, the shortcoming is, just like other dwellings, many of those databases don't take into account energy poverty, and the fact that the users have to endure a lack of comfort for economic reasons. There are many buildings which directly do not have systems which allow thermal comfort. We have a standard profile of thermal comfort whereby it's expected that all buildings should provide ideal climates during a certain number of hours, and that profile has to be applicable to all buildings. And that's not the reality. What we try to do is to get a closer idea of the real situation of users of social housing. Rafael has already explained the Vulnera project, but our work is a continuation of those vulnerability indicators that were explained by my colleague. In the case of our project, the TEP130 research group, through a series of parametric simulation models, were able to evaluate or assess the performance of this housing stock, their evolution over time, which during long periods have not used active systems, from an adaptative thermal comfort perspective, which is what we believe the majority of these users would like to achieve or obtain. In our case, we used simulation models. We used Energy Plus, which can be used, well, Energy Plus used text code, and this allows us to link the models with the MATLAB mathematical code, thus allowing us to configure these parameters and perform these simulations. And using controlled computational processes or steps, we're able to one by one simulate all of the dwellings within the housing stock, although that would be an exhaustive task. So we're able to do this through the models. So the simulation range is fairly large. Of course, for us, it's essential that these models are validated accordingly through the comparison of measurements in situ based on a selected sample of spaces within these dwellings. We know that there are many variables that have to be adjusted within these models, and once we validate those variables or measurements, we can launch the parametric simulation. To perform the parametric simulation at regional level, at regional scale, the information within the database is fundamental. That database of public housing on a rental basis is essential, as per the database of AVRA. So based on this information, we're able to establish a series of ranges of variability and also to gauge the thermal performance of these buildings, geometric, constructive and operational parameters. So using these parameters, we're able to establish matrices using the input of data into these models, which provides a wide range of cases, different cases, which are nevertheless representative of this housing stock. This is based on two basic models, which are the two typologies that were explained by Rafael, and which are the predominant ones in this housing park, which are the linear ones that he described. And for the simulations, we also used climate records from the Metionom database. These are databases which were collected between 2010 and 2020. As Ana Sanchez or Teeth mentioned, if we use climate records prior and after the technical code, then we will be obsolete in our approach. And of course, one thing that we were unable to include is Jaén province, but we were able to simulate the other provincial capitals in Andalusia. Results. We can present the results in terms of percentage of hours outside the comfort range. These are the results for the winter period in the H block. And as we can see, the results show that the entire housing stock in all of the localities are between 90 to 100% out of the hours outside the comfort range or zone. If we now focus on places like Cordoba or Granada, it's not between 90 and 100%. It's practically almost all of the dwellings during all of the hours are out of comfort. Yes, I'll speed up, says the speaker. In the case of linear blocks, well, the situation is much more uniform. There are cases with better results in places like Granada. Once again, the situation is the same. Almost 100% of hours outside of comfort. when there's a lack of comfort. In the summer, in the H block, the results are better, and the worst performing localities are Córdoba, Seville, and in third place, Granada. In terms of the linear block, once again, we observe more uniform performance or behavior, but again, the same three localities or cities perform worse. So the linear blocks perform worse in the summer than the H blocks. As a conclusion, in general, we can state that this characterization of the housing stock shows that the greatest shortcomings in terms of comfort, thermal comfort, can be identified during the winter periods. Obviously, winter periods are longer than during the summer. They are more severe, but they're shorter in time in summer. But the situation's changing, as we've all seen in recent years. In H blocks, the results are worse than in linear blocks in general. The most vulnerable localities would be Córdoba in the winter and Granada in the winter and Córdoba in the summer. And there's not always a correspondence of the results with the climatic zoning established by the Technical Building Code. For example, unusual situations, Seville is classified as B4 and Malaga A3, but the results are very similar in the summer. However, Huelva is included in B4 summer zone, and the results are much better, much more favourable than in Seville and in Malaga. So this perhaps means that the zoning system used in the Technical Building Code is obsolete and unreliable or unviable, hence the reason for many of the studies that we've been carrying out. So through this study, the idea is to complete the study that was presented by Rafael Suarez with a view to maintaining the socio-economic component applied through public databases and also established on the indicator side in relation to energy, and base this perhaps on this model, which in our opinion is closer to the reality than the energy certificates. And as Rafael also mentioned, this is also the starting point. This is the necessary starting point for the Reviva project, which is promoted by the Regional Ministry of Development, Territorial Structuring and Housing, the aim being to develop numerical optimization tools which will provide solutions to improve the situation and overcome these vulnerabilities and address the problems we face related to climate change. Thank you. Thank you very much indeed.
Thank you very much, Rocío. We're going to continue now with the next scientific presentation. I call Inés Díaz Regodón from the Renewable National Center in Spain, and her presentation is going to verse with regard about energy certifications. Thank you very much to all for providing us with the possibility of presenting this energy performance certificate under discussion presentation. I am Inés Díaz Regodón, and I work at the National Renewable Energy Center in Spain, in Pamplona. And what we do is develop research, applied research for renewable energies, and we support technologically public administrations and private ones. I want to introduce Laura Amol from the Institute for Future Energy Material Flow Systems from Germany, who has participated in this presentation. Before we begin, as a reminder, I wanted to talk about the EPC and the energy efficiency energy performance certification introduced in 2002, and its main objective was to provide information to the user of the energy efficiency of housing. After this directive was transposed in the different legislation of the different countries, each country adapted this their own way, because the directive only provided a general framework, and from there certain tools were derived, like the e-calendar in Spain or the C3X of energy certification for existing buildings by Sener and Efinobatik. And after that, we have seen new directives which have introduced certain prerequisites, new ones, to improve the quality of energy certification to the current times when the new review of the energy certification is being carried out. And energy performance certification is going to be key for the decarbonization of housing stocks. In the last 10 years, when certifications have become important, we still have remaining challenges in the whole of Europe that mean that we haven't managed to comply with the initial objective. So the lack of precision of these performance certifications, the difference between real consumption and theoretical consumption that is presented in the certification processes, the lack of protocols to include new technology, the lack of convergence between the different certificates in Europe and its countries, the lack of trust within the market, and the lack of raising awareness are elements that are problematic. So the European Commission, in this context, the European Commission creates a call for the development of energy efficiency certificates in the future. And CENER has created the e-Panacea project, which has as objective to give actually answers to these projects, and we are basing ourselves on current usage and data. We use machine learning, modeling, and all of the big data analysis tools. An important part of this project is also understanding the needs and perceptions that end users have, understanding legislators and politicians' needs, and all of the agents related to energy certification. For that, within the context of the project, we have organized a series of participatory actions. On the one hand, a series of workshops with the end users in 5 countries. 3 editions have been carried out of these workshops, and they're focused on end users of energy performance certificates because they are the occupants and owners of buildings, but also training workshops for the agents and stakeholders who are in contact directly with them and can influence the user's perception, such as certifiers, architects, energy advisors, real estate companies. On the other hand, during the 3 years of this project, we have created debate fora with policymakers and also certification institutions and other associations and professional associations. And in this right-hand side map, we have marked the different areas where we have carried out these workshops and debates. I cannot describe how we have organized it because we don't have time. We have detailed information in the different slides. Here you have the different topics that we have discussed in the different fora, and I think it's more important that we focus on the conclusions. All of them are present in the communication, but here are some and the most important ones. The end users of EPCs have very little information of what this energy certification implies, and they think that this is an administrative document that is required for the sale and buying of properties. But it doesn't really provide them with useful information with regards to how much is consumed or how much they spend on heating their building, and it doesn't serve as orientation to understand how to renovate the building. They're interested in understanding the real energy that the building uses up, the real cost that is going to have a representation in their bills. They want to see individual improvements when they consider rehabilitation. This has also been discussed in the regional debate boards with legislators. They understand this, but they keep insisting on the fact that we shouldn't forget the origin of this tool, which was to compare the energy efficiency and thermal quality of all of the buildings, to do so as well in lab conditions. And so this is not really useful for certain aspects. They also add that adding more information means that it's going to make it more complex and difficult to understand this document for end users. In any case, the ePanacea project proposes a way to integrate the end user dimension, providing supplementary information for the end users. And here on the right-hand side, you can see the templates for the energy performance certificates, also templates discussed in the fora, which can be administrative information that includes more information adapted to the needs of the end user. Some of the conclusions and recommendations derived from our research and debates are aimed at the future generation of energy certificates. We really have to bear in mind the end user dimension, include protocols that allow for the inclusion of new technologies, using real monitored data, provides recommendations and improvements that are linked to end-user behavior, and that these recommendations be related to the optimization of costs, as we include in ePanacea, and provide also roadmaps that establish rehabilitation steps and building renovation steps, which is also linked to energy passports, and allow these certificates to provide information which is twofold. On the one hand, linked to the needs of the public administrations based on operational conditions, and on the other hand, the needs, something that caters to the needs of the user with real data. It's also important to have partial indicators that allow the technical staff to define easily the improvement measures that can be carried out. And also, end users pointed out that they wanted additional indicators such as air quality or thermal comfort. Introducing those would be interesting. Also, having references, for instance, quantity of CO2 doesn't give a lot of information, but having a comparative number may aid in understanding if it's a lot or not. Creating a new set of web-based tools that include all of the cloud computing power, as we include in ePanacea, which integrates measures such as automatic calibration of inverse modeling. Other recommendations, like there be registers of EPCs, that site visits be mandatory, better improved training, and better communication through intermediaries and certifiers, real estate agencies, and that the digital be digital and dynamic, so that it's linked to databases that can be updated, which gather information about energy costs, conversion factors, investment costs, and so on. And this will allow for this document to be a live one and an ever-changing one, and obviously that the information that is used in this document be simple with graphic representations, clear and short, so that end users can understand this. As you can see, I have not been able to explain in depth, but please go to our website to understand. And I would like to thank you, all of my Ibanacía team, and I urge you to visit our website, like I said, where you will have a lot more information about energy certifications and the next generation of energy certificates and the THENED methodology.
Thank you, Inés.
Siguiente ponencia.
The next speaker is María Martín Morales. The title of her presentation is The Evolution of Bioclimatic Architecture and Social Housing Through a Biometric Analysis from the University of Granada. Thank you. Thank you. This presentation has been prepared by Dr. Montserrat Zamorano together with the student Dana Alexandra Rus, a PhD student from the University of Cluj-Napoca. The study is structured as follows. These different sections which I'll run through. Over the last 2 days we've highlighted the importance of energy consumption and comfort in social dwellings. The construction sector consumes approximately 40% of the energy worldwide. So it's clear that the construction sector has to make important efforts to reduce the environmental impacts of buildings through energy savings, thermal comfort, etc. I apologize, but there's a problem with the presentation. The bioclimatic architecture is, let's say, a new form or new way of designing buildings that takes advantage of vernacular architecture, incorporating technologies and methodologies that are much more innovative in order to achieve the necessary comfort of buildings and to improve user health and thus achieve energy efficiency based on strategies incorporating devices or elements that will provide shade, passive energy systems, thermal mass strategies, ventilation strategies, etc. Bioclimatic architecture has traditionally been developed in tropical or arid areas. So, in our opinion, we all understand that social housing has developed in order to support less or more disadvantaged citizens. Well, this type of housing is faster or can be constructed more quickly. So, in our opinion, the construction of social housing in accordance with the concept of bioclimatic architecture is very interesting. There's indexed scientific publications with studies on bioclimatic architecture. We used the Scopus database and also the VOSViewer tool. In Scopus, we performed a prior search, basically using the keywords or key terms bioclimatic architecture and social housing. There were certain limitations: language, English is the universal language in scientific publications, and other limitations was the number of documents, scientific journals, conferences and book chapters. Using the Voss Viewer online tool, basically we're able to develop scientific maps that we analysed in order to analyse and study these type of data. For example, annual scientific production until 2022, keywords, scientific production by countries, authors, sources and documents. Paradoxically, we only identified 33 scientific papers. Those 33 scientific papers are distributed in the graph as follows. The first publications appeared in 2005, which is fairly late, or only recent. That's because there was a scientific conference at which these documents were published. Then there was a gap until 2010, and from 2010 we've seen that scientific papers haven't actually increased much in number. As regards the keywords that we identified 331 keywords, and according to the graph that we obtained with the tool, we observed that those keywords were very well interconnected. The importance of the study topics is largely based on the occurrence of those keywords. So of the 331 keywords, there are 12 that are repeated. Sorry, there are keywords, as the lady did, repeated up to 12 times, namely social housing, housing and energy efficiency. And this highlights the importance of energy and energy efficiency in social housing. In turn, there were another 4 keywords which occurred 8 times: architectural design, highlighting its importance. There were 7 occurrences of 6 keywords: energy use, thermal comfort, sustainable, and then with 8, sustainable development. Sorry, the lady corrects herself. There were 8 keywords that occurred 5 times: sustainable development, bioclimatic design. In terms of scientific production by countries, this shows us that the country with most scientific output is Brazil, followed by Chile. In 10 years, only 5 documents: Mexico, Colombia and Italy. And the figure also shows that there was no connection between any of the countries. So this reveals that there's not much interest in coordinating bioclimatic architecture literature in social housing. By authors, well, we were able to come up with a list of the main authors. Maria Alpuche is the author with most articles, but there's nevertheless with less impact in scientific knowledge terms. She's closely connected with the 2nd and 3rd authors in the ranking. And then the authors ranked from 4 to 8 are somehow connected at scientific publication level, with only 1 article each, but with a large number of citations. And then we have authors at the bottom of the list, because although they only have 1 article published, according to the number of citations, they seem to be of greater quality. But with the Voss Viewer tool, once again we observed that there was no connection between any of these authors. As regards published sources, the table indicates that virtually all of the sources were high-impact journals, practically in the 1st and 2nd percentile of the scientific journal report, but very few articles indeed published. And the most relevant documents in the study are ranked from greater to lesser relevance according to the number of citations. The aim of all of these studies focuses on achieving greater performance, particularly in social housing, greater energy performance, and the achievement of better comfort levels and energy efficiency. Well, what can we say then in conclusion? Well, bioclimatic architecture seems not to have been developed in social housing, or at least adequately. And this is perhaps one of the reasons for a lack of scientific studies, according to the indexed databases. More specifically, there are countries that have developed more such studies. We can highlight Chile, Brazil and Spain, all countries which are located in high temperature climate zones. There was hardly any relationship between authors from different countries, so this doesn't enrich scientific knowledge very much. What is important, however, is that despite the small number of publications, they have been published in high-impact scientific journals, according to the Journal Citation Report. Thank you very much for your attention. These are the references that we used, and there you have my contact details if you require any further information. Thank you.
Muchísimas gracias, María. Y ahora...
Thank you very much, Maria. And now, the round table. Good practice cases and then a debate. I'm going to go through all of the participants, and I'm only going to focus on those that we haven't presented and introduced here before. And then, so for this round table, I will ask Montserrat Zamorano to join us on the stage, José Sánchez Ramos, Ana Sánchez Ostiz, Rafael Suárez Medina, and Valentín Molina Moreno. And María de la Barca, who is going to be the moderator. Please join us here on the stage. This round table is going to be moderated by María de la Barca. Welcome. She is architect and secretary of the Andalusian Council of Architects Association, has more than 24 years of experience working for public work and freelance. She has carried out rehabilitation of buildings for tourist and public use, rehabilitation of buildings with concrete and wood, and she loves building with wood. She specialized in management and preservation of heritage projects of providing value to heritage. She has been collaborating with the University of Granada, and this is just one of the brief example of her CV. We had 5 speakers in this round table, and I'm going to read the CV, and Maria will then introduce them. 2 of them are going to make a presentation. I will read the title, and then afterwards we will have the conversation. Montserrat Zamorano Toro, professor of the area of technology and environment in the Advanced Technical School of the University of Granada. The civil engineering. She has published more than 100 works in international magazines, and she directs the chair Hidralia since 2016, co-director of the chair La Huella Verde for the Granada Sustainable Transformation, and she was awarded the Medal of Andalucía for the environmental merit. And the title of her presentation is The End of Waste and Subproducts and Engines for a Circular Economy. And José Sánchez is also going to present another best practices presentation. He is professor of the University of Seville, researcher in thermotechnia, and together with Fernando Álvarez, he co-directs this research group of the University of Seville. He's participated in more than 15 international projects and 20 national projects, and 80 transfer contracts, being the lead researcher. The research topics that they focus on from 1979 are thermal behavior of buildings and energy efficiency, energy management of buildings and installations, and urban climate and its impact on buildings. His speech is going to verse on the integration of natural techniques for buildings. Ana, who is from the Technical School of the University of Navarra, Rafael Suárez, University of Seville, and Valentín Molina, University of Granada. Thank you. Thank you for inviting us here. I would first of all like to ask Montserrat to start with her presentation. Montserrat Zamorano is going to talk to us briefly. About the end of waste and subproducts, the main drivers towards a circular economy.
Muchas gracias. Bueno, pues,
Thank you very much. Good afternoon. First of all, I would like to thank the organization for inviting me to be part of this roundtable. When they asked me to participate, I thought about what would be important to talk about in this debate. And focusing on building and circular economy, I wanted to bring to you how finding the end of waste and subproducts means that this is going to drive circular economy, and it will make it possible. We all know what circular economy means. We know that it is a change in the way that we think and in the way that we produce and in the way that we consume. One of the fundamental elements of this is trying to include in the productive cycle different waste so that we can lengthen the life of these products. The recycling of waste is not the only pillar, but it's one of the main pillars of circular economy and is very relevant. One of the main problems with regards to waste when we want to implement this new economic model is the difficulty of introducing waste in these productive cycles. And this is difficult because, on the one hand, there is very much lack of knowledge of how to reuse waste, then that there isn't technology that allows us to recycle or reuse part of this waste, and also lack of confidence from producers because they don't want to use this waste as a raw material in the productive cycles. Because substituting natural raw materials for waste, people are a little reticent. Also, it's important to understand that there is legislation that limits the introduction of certain products in the productive cycle when it is considered as waste, because legally there are limitations and percentages of use, despite the fact that it may have an equivalent quality of the natural product. There are many examples of this. Many years ago, when we started using the waste of water treatment plants, and when we changed the name to biostabilizing material instead of waste, it really made a difference. With regards to the building and construction industry, there are many difficulties in introducing in construction spheres material waste for building. So we have waste treatment plants that have a lot of subproducts which we can recycle from construction waste, and they don't have a market for these elements. So there are two concepts that are included and have been for the last few years within the waste and contaminated land law 7/2022 of the Spanish legal framework, and there are two concepts that we have to transfer to our legal framework that will be drivers of circular economy. And on the one hand, we have the understanding of subproducts. The current waste law, which together with the European framework defines the conditions under which a substance that results from a production process can be considered as a sub-product and not as waste. This is the list of the different properties and conditions that the sub-product has to comply with, and they have to be simultaneous. We have to make sure that this substance can be used directly without it being transformed, that this substance that is part of the production process, and it won't have environmental or human health detrimental effects. Within this law, we also find the concept of end of waste. And waste that have gone recycling will stop being considered as waste, but they have to also comply with a series of conditions that substance have a means of being used, that there is a guaranteed market of these substances, that these substances comply with the technical prerequisites for a specific means, and the legislation exists for regulating the use of these products, and also that these substances don't have negative effects on health or the environment. With this quick presentation of what a subproduct is and what the end of waste consideration is, we tend to have the false or the misunderstanding that in this image the middle dot is smaller in one of these two images, but that's not true, and the same thing happens with waste. The concept of subproduct avoids us from thinking that the way that this material has been generated is waste. But the end of understanding waste as waste itself, so categorizing it differently, then this changes the way we consider it. So the option that we have is, and what we want to achieve, is reintroducing this product in the productive cycle. And these two differentiations mean that we go into the cycle at different standpoints. Autonomous regions are the ones that can evaluate and authorize the condition or the definition of subproduct or end of waste definition. The autonomous regions can rely on their departments and ministries to evaluate what kind of subproduct this is. And in any case, the consequences are important, that the product is going to be introduced in the productive cycle. When it's a subproduct or the end of waste condition, we cannot apply the legal framework of waste and this means that these materials have a possibility of use that they wouldn't have if they were considered waste. With regards to the end of waste definition, specifically in this case, the fact that we apply the end of waste status will have consequences in terms of recycling and the valuing of this product, among which I would like to highlight the filing. From the point of view of the administrative classification, when something is not considered as waste, this means that the bureaucratic and paperwork required and linked to waste is eliminated. This in itself is a great advantage because all of the facilities in the sector that needs to be pushed forth with regards to the value means that this product is going to be more competitive, and also it's going to allow for important investment to be made in the sectors that can use these products, that will allow to create products that have characteristics that are competitive and that allow the fulfilling of the regulations that are applicable. A good example is the use of the áridos, so arids. What comes from a plant is not a residue of aggregates, These aggregates, when they are derived from waste, have the same characteristics as the natural aggregates, and so they're going to be more competitive, and we're going to push and foster the sector, and this will allow for circular economy to be a fact. Andalusia pioneers in this sense, and we have a law that has recently been approved, the circular economy law, and it encompasses these two aspects. In Article 32 it talks about subproducts, 33 and 34 it talks about the end of waste status. There's going to be a department that is going to deal with circular economy, and they are going to be in charge of the paperwork that will allow for the change of status of waste and generate new products that will derive from the waste treatment plant. And in any case, I would like to add that for this circular economy law that has just been approved in our autonomous region, for it to reach its recycling objectives, we have to change the legal framework first. There has to be a legal framework that allows us to apply the concept of subproduct and the end of waste status, because they are essential in order to move forward in circular economy, to value again the products and guarantee that there is a demand and a market for them. And of course, making waste management companies into a sector that will be key for fostering circular economy and achieving the recycling objectives in Europe and in Spain, of course. Without developing the legal framework for this, the subproducts and end of waste status, all of these recycling objectives will not be achieved. That's all on my behalf. Thank you very much for your attention.
Muchas gracias, Montserrat.
Thank you very much, Montserrat. I think it's very interesting to talk about the circular economy and also the reuse of waste, which ceased to be treated as waste. And those of us who work in the construction sector, we're aware that the construction sector is the major source of employment in Spain. So if we can provide some pointers as to how construction companies should adapt in relation to these regulatory adaptations and promote this innovation and thus become a competitive sector from an economic perspective, well, that way I'm sure we'll be able to achieve those recycling objectives that are set at European and Spanish level. Okay. I'd now like to move on to the presentation by José Sánchez.
José, ¿se pone sol? Se pone sol. Vale. Vale. Que viene, que viene, que viene. Digo, a ver si me apaga el ordenador. No está.
Una pausa última.
Sí, a última hora. Me ha mandado un mensaje diciendo está en tal sitio.
¿Qué nivel tenés?
Aquí dice hola de nuevo. Esta es la número 2 de la carpeta, mesa redonda 12B3. Me lo podéis ahí. Gracias. Mesa redonda, no sé qué. No, no. Mala leche.
Voy a buscarlo.
Sí, vale. Esto pasa hasta en las mejores casas, o sea que
This happens even in the best of places.
puedo empezar a pecho descubierto para no delatar.
I could perhaps improvise so that we don't delay things a little while we're waiting for the presentation. This was a poisonous invitation, a toxic invitation, because, you know, these type of things happen when... My name is José Sánchez Ramo. I represent the Grupo Termia, and all I'm going to be able to give you a snapshot. We've got 4 main lines of research, as you all know, and the presentation I wanted to give focused on practical solutions and cases and where we see the opportunities lying, a roadmap that we should try to ingrain in our minds and see this as the path forward. I was fortunate to participate in the previous session. I found the presentations extremely interesting. We have a strong relationship with everything that you're doing. So I was really crying out of pride and satisfaction at what I was listening to. I've slept much less due to HULC, the LIDA unified and columns unified tool than family problems. And, you know, I focused more on the technical and scientific conceptual developments. I'll explain exactly where the shortcomings lie in that regulation. We continue to work with them, but on a lesser level. Things are not the same. The spirit's changed. So, Belen, if you were to close your eyes, you don't need a new simulation tool to verify the regulation. This was treated as the G case. So the spirit of demand has been lost. And this patio effect that our colleague mentioned is so relevant. These type of things disappear. Certification is something extremely cumbersome because certification involves a comparison with a common denominator. So this is extremely full of pitfalls. You cannot imagine how many. For example, the blinds of this simulation during the winter when they're open. Imagine the summer, a person who's got to take a decision like that. So we're talking at something very top level. And there are many other hypotheses that stem from this, which fall within the tolerance of 3, 4, 5, 6% variation with respect to the results. So something that can say 4, 5, 6%, well, that's questionable. So what about climate change and climate impacts? And the impact of your real users, all of this is full of pitfalls. Because one thing that we were applauded for was the concept and definition of a standard user. A standard user is this common denominator I referred to before. It was also mentioned by another colleague. You won't believe it, when we perform simulations with the official tools, we expect that all dwellings have climate control systems, because otherwise, the question will then be, to what extent are we able to develop this, which is very relevant. But it's full of pitfalls, because 1 degree and 10 degrees are not the same. So on day 1, you've got to weigh this, and what weightings can we use? What are we going to do with this? There are lots of shortcomings. So my presentation was going to focus on cooling. I'm going to base my presentation on Montserrat's results, and I hope that the presentation arrives, because otherwise I'm not going to be able to continue. And my presentation will lose its impact and its interest. And there is some really spectacular, interesting stuff in there, so please bear with me. We'll see you back in 5 minutes. We'll wait for the presentation to be put on the computer. Well, I'm not sure. What do you think? Perhaps we could start the debate, and then we were delighted to be able to give the presentation later if it comes. Shall we start the debate? Okay, right, to kick things off. Is everyone in agreement? Well, okay. To kick off this debate, you can not just respond to my comments, but also to any questions that may come from wonderful speakers. There are a couple of things that drew my attention. As an architect, Anna's comment was very interesting, particularly extrapolating the situation to Andalusia, where the majority of municipalities have no winter. Granada does, but many municipalities don't, where it's not sufficient just to design and simulate in a winter scenario. What else do we need? We need a change of paradigm, and we need to design based on summer conditions. We have to think about how we can rethink some of these tools, and also the different simulations that take into account local residential or district microclimates, which is also extremely interesting. And this links up with many of the interesting things that have been said, not just in relation to building renovation. And things come to mind regarding the contents of the urban development plans to ensure that we can still foster the exchange of moisture, humidity, and maintain temperatures, which is something that was maintained in many of the historical centres or quarters of many of our cities. And another very interesting comment was that we should think that users have to be able to use buildings and provide them with the necessary tools in order to perform this control, whether we're talking about social housing or rented accommodation. And this, the importance of economic capacity and also comfort. I'm not sure who tried to close that circle, and also a comment about solar protection systems. I found it very interesting that we visualize all of these points and the ways in which we can maintain dwellings cool using all of the tools that we're designing. And obviously in many public housing, the way that they're designed, they would probably have to have the blinds down all day. And Rafael, shall I continue or what? And as regards Rafael's presentation, I thought it was very interesting to hear that we should always remember that the dwellings that we live in 20 years have already been built. We know about the way things should be done, but what do we do with what we already have? You also referred to social vulnerability. And I think that with all of the examples that have been presented, we all understand what we're talking about when we discuss public social housing or dwellings for rental. What about our schools? I've got 3 children, and parents sometimes say that what is being built today is not for chicken, it's meant to be for human beings. What about elderly people's homes? The same applies there. And that some of these new homes respond very poorly to the increase in heat. And I think it's important to highlight the importance of comfort levels, and that we shouldn't just focus on energy expenditure but also comfort. And to conclude, I know that thermal conditions are inadequate due to the low level of characteristics in many of these social housing complexes. Anyway, some of you also referred to the need, given this scenario, to establish an order of priority. Because in the existing housing park, housing stock, we're not going to achieve these targets. Because in places like Granada, it was mentioned that there is no thermal comfort at any time of the day. So we really have to establish priorities, or at least start to rethink things to try to achieve the homes or dwellings that we want to provide better thermal comfort. Level, but also at district or neighbourhood level. Who would like to follow on and respond? I will start. Thank you very much. Well, as a professor at the architecture school and as a representative of the profession, I think it's important that we understand that the profession faces a complex challenge. And I say complex because some of the things that we're seeing make me rather fearful. I would describe certain approaches or actions as very standard or basic, and perhaps not sufficiently well thought. And perhaps we've monitored some of those, and then we've performed the assessment in a scenario of climate change, and we're going to have to renovate what's already been renovated, and that is an aberration. That's an aberration. There's a problem here, and I think we have to keep this in mind. I think there's a certain degree of regulatory determinism which attributes enormous value to 2 aspects, airtightness and thermal comfort, which is all very well and good. And I think that Rosa mentioned this before. And I think the change since 2019 has been evident with the loss of certain concepts. Where is climate inertia? And the concept of inertia in the Mediterranean is fundamental. When it's hot, the only option that we have is to seal everything and wait to dissipate the heat at night. There's not really much more we can do. So, obviously constructors have to base their approach on regulations, but perhaps the starting point is erroneous. The regulation is based on this thermodynamic balance, which really makes little sense. Climate is a phenomenon of exchange, the exchange of ventilation, solar radiation. Therefore, the conditions are very different, and that has to be kept in mind. Because I think that we really have to provide more guarantees if we're going to address these changes in the future. You also mentioned the importance of scale. And I think it's important to work on a lower scale at district or neighbourhood level, because the problems, obviously, the major problems are at a greater scale. But there is also a problem there with industrialization, which I believe to be fundamental. because that relationship between industrialization and architecture is rather unclear. It's almost as if the architect is disappearing some way. So architecture must support industrialization, but industrialization is like a catalogue of elements which we need in order to start working. There are also certain colleagues that don't wish to accept these type of projects because for them they consider that energy efficiency has to be something that is within the sphere of responsibility of architects. José Ángel de la Sota said that architecture begins with actually doing architecture. And basically de la Sota said that you just have to pull up your shirt sleeves and get down to it. Just do architecture. At district or neighborhood level, what would you like to say? I think that the current configuration of neighborhoods or districts means that they're very dense. Free spaces are often occupied by cars instead of by nature. So we clearly believe that it's important to include the urban environment in these simulations to ensure that simulations are adequate. But we believe that we have to act at neighborhood or district level, incorporating more green areas, green zones. Typology is very important. Rocío said that the H block is more effective than the linear block, albeit despite the worse orientation, because an interior patio of an H block, as we've seen in other cases, may be beneficial. Nevertheless, we have to remember that roofing and facades also contribute to overheating. So we have to consider what materials are used or construction solutions are used in these facades or roofing. Ventilated roofing, ventilated facades, in order to improve the performance of top floors or facades, or for example those that face south or east, southwest or south. So orientation is fundamental. What we've got to do is to stop the heat during the day and then dissipate at night. We've got to create barriers to heat during the day and dissipate at night. And we've seen the surveys and the results very clearly. People don't know how to use their properties, their dwellings, and less so when the dwelling is a passive house dweller with a heat recovering device or system. And there's a lot of overheating due to the fact that people are not using those dwellings correctly. And what about the concept of solar protection compared with lowering the blinds completely? There are also systems that combine, let's see, flexible slats in the blinds which allow natural light to come in but not heat, because otherwise we're consuming artificial light and overheating the dwellings. And what about fixed elements? Well, these are independent from user behavior. A user may go to work in the morning and sees that it's cloudy, but it's possible that the conditions may change during the day, the sun may come out, and when they get home their dwelling is overheated. So all types of elements that will help improve this behavior are important. In the case of dwellings in the north, they have to be made from dark bricks because they will absorb the heat during the winter. That is a mistaken belief. What they can observe once solar radiation passes and the temperature is lower again will move to the exterior, not towards the interior. And in the summer it's not the case. So these facades may have low absorption rates because they will actually serve as a barrier to the solar radiation on the exterior. What about these large vacuums or empty spaces? Yes, well, we can do them, but build them, but they have to be done correctly and provide ways in which we can stop solar radiation. Unfortunately, we cannot hear what the lady's saying because the microphone's not turned on. Jose, you can give your presentation when you consider fit. Okay, I'd just like to make one final comment. The technical code and the way in which performance and behavior is perceived in the summer. In the winter it's okay. Air tightness, in the latest amendment, 2019 amendment, the 4 important concepts have been included. But We can calculate this curve during the winter or the summer. But if somebody works at home during the day, will the person always have the blinds lowered? No, that's not possible. We have to try to construct buildings that respond to today's social needs, for example. And what else does it take into account? Well, the new technical code considers that the temperature should never be 4 degrees higher than the comfort temperature all year round. But there's a trick here. You may have a passive house dwelling that doesn't consume any energy in the winter, and you're at comfort temperature, but in the summer, when the heat gets in and penetrates the dwelling, and we've monitored with passive house buildings, what are the temperatures outside the comfort temperature? Well, all during the entire summer. But for this dwelling, it will calculate them for the whole year, not with respect to the summer or the winter. So there are certain things that we have to improve enormously within the technical code, because we are performing simulations which show that the reality is completely different. We're always trying to reduce the gap between what's been simulated and actually the real scenario. And the regulations provide us with a certain room for manoeuvre. You may disagree with me, Jose, but I believe that it's important that we, obviously prioritize strategies depending on the climate zone. The north of Spain is not the same as the south. And something that we've already beginning to see in the north is that we're having enormous overheating problems. And according to the technical code, there is no problem of overheating, and that houses or buildings are operating effectively. And now I'll give you the floor perhaps, and we can listen to Jose's presentation, and then after that we can talk a little bit about materials in connection with this sensorial strategy that we referred to before.
Que tienes que hacerla con la misma...
Unfortunately, we can't hear the gentleman. The microphone's not working yet.
Ayer estaba de viaje, ayer tuve un viaje interminable por París, y le decía a uno de la agencia de luces que no lo voy a decir, me juro ante Dios que no me falle la célula madre para decir el nombre, porque perdería toda su amistad, la poquita que nos puede quedar. Y le decía aquí yo.
Yesterday, I was saying to someone
que si hace mucha calor a las 12 te mandan a los tronos.
that they were talking about a school that we had done renovation on to improve the roof of the school, to stop it from being so warm. We're going from bad to worse, really. Montserrat already pointed out to the fact that on the top we have the climatic records, the average of the last 30 years. And from this situation, we get rid of the blues. Blue is the color of cold. And what we see on the bottom is what the future has in store for us, which is overheating. These good practices really stem from the paragraph in the center. The technical regulation always measures heating. Heating is like a fur coat, and all of a sudden it's like having a fur coat in the middle of summer, in the height of summer. Imagine this situation in schools, where everyone is emitting heat, and if you open the window, things are worse because the heat comes in from the outside. The new European directive shares with us information about the HD0 and the zero net buildings, and in Spain it's those that follow the technical regulations, and that's not so true. the source of natural ventilation are going to be considered as natural resources. So it's going to be equated to a PV panel. So this is, imagine this situation is going to be applied to school, is going to be applied to buildings, is going to be applied to everything. And this in Seville is really quite important because it gets really, really warm. And also the effect of the heat that the buildings radiate also affects the temperature too. What I wanted to propose is have a twofold understanding of constructive elements, finding the industrialization of them and including a second derivative, the integration of not PV panels but another industrialized solution. We test our ideas. We have holodeck on the left-hand side. In the structures of wrought iron, holodeck provides piping that moves water around. And the message may be conflicting because you think that there's going to be water in your building, in the structure of your building, but this will be a great cooling system. Because being able to reduce the temperature at night is very important. How do I ventilate at night a building? What we are trying to do is introducing in constructive elements is within the actual structure, including ways of circulating. We have a concrete element on the right-hand side, which has, for instance, an air chamber. In Abra, Elena, Jorge, Marta, Sergio want to introduce this and have introduced it in building. On the left-hand side, we have the example of Menjiva, and we have examples where it was brought into effect in 14 blocks of flats, and on the right-hand side we have La Estrella in Gamas. Some of this data was presented yesterday. The comparison between one block which is refurbished with the 2.0 initiative, and the other ones are not constructed the same way. They've got different solutions. When we compare the temperatures in the ceiling and in the roof, when we get a reduction of 4 degrees, and the surface is therefore colder. This is all very interesting because they have been able to integrate it within a project which is carried out publicly, and it has an admissible overcost. What we believe should be highlighted is introducing water, because moving air requires a lot of different sizes. So if we use water, we can get water from rivers or redirect waters of and using it to cool can be very interesting. The way to cool water is to pour it over the PV panel. That way we generate a cascade of water over the PV, and within the climates that we have, not a lot of water evaporates, so we can actually reduce the temperature to 17 or 18 degrees Celsius. And we can't have great volumes of water, just small volumes of water. And this is a very good solution for roofs, and we have several listed here. And we're talking about roofs because facades, for instance, have a lot of elements on them, but roofs tend to be quite bare, and so they can be used for installing different elements to produce. And here are solutions that we propose, and we're working together with Danosa to integrate these solutions for their portfolio. This is an example of how they would be used on roofs and how the water would be channeled. And it'd be as easy of introducing a coil and a pump. We would have to accumulate water though. And basically we can't do this and in only one building. So we should build for people and bring together very many buildings in order to do this. Public spaces really should allow for the intervention in buildings to do this together, because if not, the public management is ignoring building, and the buildings are ignoring public management, and so it doesn't work. There are a lot of possibilities for synergy between the two, because they have a lot of possibility of exchanges. So, it is in line with this that we are working, and here are some examples of a European project where we had an urban lab. In public spaces, you can do this sort of. These are concrete laden conduct channeling devices, which can be done well. And doing this, we can be able to reduce and cool an area of a 1,000 square meter area. So this guarantees that the cooling is possible for such a large area. This has been done, and we have experimented with this type of initiative in Seville. It is possible to do this in these types of projects, and I'm sorry that I don't have the photograph, but at project level we can intervene in public spaces because people are motivated to be outside because of all of the reasons that we already know. When Vallecas in Madrid was increased, they introduced a lot of avenues and buildings. A lot of PV systems can be included in public spaces, and there can be water gathering systems, and they can be used for cooling, and they can be connected directly with buildings. Because all we need is a return piping that goes and returns from the building. And this would allow us to connect to collecting devices. And this can be good for cooling. And in the return collector, for instance, we can gather the water, we can bring it to a cooling device, and we can do all of this in public spaces. What's so wonderful about this is that we can include PV everywhere, and we would perhaps consume only 34% of the energy created, so the rest can be used for urban spaces, and it's also very important to use this in urban spaces. And this is the example of the school that we saw yesterday. This school had a structure which had a cooling roof. The patio or the courtyard in this school is where the kindergarten children were, and what we wanted to do was to control the amount of heat and create a colder environment. And so the rainwater that was gathered was used for this. And not only does the water run through the ceiling, through the roof, and allow to the cooling of the area, but also it cools the air so that the air can then be redirected to the different rooms or the different classrooms. And these things can be done, and they are possible because we are using all of the elements available. And so creativity and architectural firms can go a long way. This is the concept of the grid, and really while they are redoing a road, for instance, they can add all of these techniques to when they are when they're refurbishing the road. The water can be reused, and they can be used for watering systems of plants and stuff, but the water can also be at the same time used for cooling. So what I wanted to share with you is that we need to think about cooling from the point of view of the many uses it has. What has been very useful for us is the fact that Spain has a lot of climatic areas, and that richness allows us to include very many possibilities. And if we increase our actions to what is around buildings, it would allow us to do a lot of work, and very positive work.
Muchas gracias.
Thank you very much for giving us the details. That's just an additional ingredient that we can add to our buildings to improve the conditioning of spaces. Well, we've got 5 minutes, but instead of talking of construction and materials, I would like Valentin to talk to us about, since I apologize, but the gentleman's microphone is... We'll have to see how research centres can help resolve the problems that we have. There's a negative externality when you refer to leaving blinds down. You know that Spain lacks vitamin D. A country with the most hours of sun in Europe, doctors have to administer vitamin D because windows are closed in most houses or blinds are down. What is the cost of vitamin D which is being prescribed by doctors? But the majority of people need vitamin D because they keep their window blinds down, and that's a negative externality of the way in which buildings have to be used, and also the way in which we should address their performance. So you've got to go to the doctor to be prescribed vitamin D because you've got your blinds down all day at home and no sunlight comes in. And this is similar to what you mentioned about the blinds and all of these devices that can be used. So we can reduce an external negative externality through the incorporation of new systems to enable sunlight to come in. Secondly, my colleague Zamorano referred to circular economy in Andalusia. Why can't we consider developing a market of technological nutrients and waste that can be recycled? If you were to change the word sludge to nutrient and call sludge nutrients, then... And we could do the same with many raw materials. I apologise, but the audio is extremely poor and it's very difficult to translate. The European Union is a net importer of raw materials. And we cannot allow this to happen from geopolitical and social standpoint. We have to use Europe's endogenous resources. That is what we focus on in the circular economy. We cannot continue to import when we have this capacity. How much can we save in gas and oil with these type of technologies? That's another negative externality in economic terms, which we have to resolve. So that raw materials market and its the sub or byproducts market, which should be developed by the Andalusian Circular Economy Office, must be a priority. What value do these materials have? In public tenders, we should prioritize those that purchase or procure materials here rather than another continent. Will I receive any type of benefit as a constructor, as a developer, if that material is produced in my country or in my region? And is that going to mean that it's more valuable than importing this from elsewhere? These are questions. The questions are the same, but we need to come up with different answers. And the Andalusian Circular Economy Office, which stems from the Andalusian bioeconomy law, aims to, quote unquote, provide a little rationale to everything we're doing. Because negative externalities stemming from poor health. We showed a picture of a sick building before. How much does all of this cost? You know, dwellings, homes are the most important asset for human beings because it provides that security and comfort. And please, if you will allow me, I apologize again, the audio is cutting out continually and it's very difficult to translate. There are more people, more disabled people, more people with mental and sensorial impairments. Should we incorporate sensors in renovation projects? We're referring to sensorial comfort. Comfort. When I give my electronic engineering classes, we also incorporate sustain. I apologize, but the audio is cutting out continually. It's impossible to translate. Infrastructures that will also improve our sensorial comfort. In short, circular economy, it's not just a single concept, it's a paradigm. I apologize, but it's impossible to translate because the gentleman's microphone is cutting out continually. We have technology, innovation. We have all of these different things. They're spectacular. We have to look at ways in which we can resolve these problems. So those are just my reflections. It's a collaboration between suppliers, developers, researchers, etc. Competition in circular economy in order to address this paradigm. I don't think there's any other option, in my humble opinion. I've got loads and loads of data. You know that the majority of tools in Spain were developed until the 1980s. The majority of dwellings or buildings in Spain need to be renovated in order to improve their energy efficiency. And in this respect, I would also like to just contribute my ideas regarding sensoriality. And the challenges are tremendous. The climate change data are really, really worrying. You can believe them or you don't. So I think that architecture has to be in the front line to mitigate the effects of climate change. You can accept it or you can reject it, but we've all seen what's happening with the increase in temperature levels. And you saw that graph of blues and reds. You know, even in measurements of climate change, we're using colour graphs. But we've got technology to address this, and it's been demonstrated in these presentations. So the idea is to encourage that competitiveness between the competitivity among all the stakeholders involved. That's my reflection. Thank you. Thank you, Valentin. Well, I don't want to wrap up this round table without giving the floor to any of the participants and without asking if you would like to make any final comments, particularly Montserrat, because I didn't give her the opportunity to say anything. I'll ask anyone from any of the participants if they would like to ask any questions, please.
Si se dirigen a ti, digo. Le pasamos a nosotros el micrófono directamente. Quedan 2 minutos.
Sí. Sí, buenas tardes.
Good afternoon. My name is Emilio Gomez. I'm the Assistant Director of Finca Bueno. A comment for José Sánchez and your thermothermia group in Seville.
deciros que os acompañamos, perdón, en el insomnio que tenéis con la herramienta unificada.
We also share the sleep. We're also losing sleep regarding the problems that you addressed. And when it comes to making sure that users will actually use things properly, we don't only share your problems, but we've also got pharmacies. The chemists are actually they have got no more anxiolytic drugs in supply due to the stress that's being caused by this. Well, the alternative to the tool is XLC3, which I think would be a way of combating it. The tool is very complete. It's loads of capabilities. It's underpinned by thousands of programs, but there's another opportunity here. Recognized, acknowledged procedural level here in Spain, with the exception of one, with Energy Plus. It's the only one that fulfills the IEA standard, because none of the others have managed to send a report on the quality controls as this has done. What is true, however, is that user faults is an area which actually really undermines everything we've done, because we receive lots of complaints there, but I lose sleep precisely there. And I'm sure that the same thing happens to you. It's one of its strengths, and that's one of the reasons why it's the only one that's financed by the Ministry of Development. So when 15 people raised their arms to say that they were going to develop this, that procedure only ended up at the candidacy stage, but it has to be fine-tuned, and I agree entirely. We're the first ones who, when we tried to use this, even with Monse, because we're working together on one of these projects, all that there are problems, because the person's responsible for testing to ensuring that the problems can be reported accordingly. Well, I don't want to say any more. I'll leave that just open. Thank you for the comments. I apologise, but we cannot hear without a microphone. I'd like to ask Montserrat, perhaps you can just make some comments about the current situation of waste, whether we're on the right path, whether we're not, whether we have to really get our act together. Well, in the current situation in Spain regarding waste management is not really very rosy. It doesn't necessarily depend exclusively on the sector, but the recycling rates are very low, elimination rates are very high. In fact, certain figures for recycling have to be used with caution because they're not really reflecting the reality, the real situation. I'd like to make one final reflection on the direction we should head in, whether we should move towards greater unification or sustainable construction. It always seems that we talk in energy terms, but energy is only part of this. We're going to have to renovate many dwellings. How? But we can't only address this from an energy perspective. We have to base this on a life cycle analysis, and more than that, a sustainable life cycle assessment or analysis. If we don't do this, we may think that we're doing things well, but we're not doing this correctly. We may be using materials which in the construction process may have consumed much more energy than the energy that we're going to save. So we shouldn't only look at the usage part or just consider recycling. We have to consider the life cycle and the life cycle assessment. In this respect, Europe, a couple of years ago, closed levels, which is a methodology which was designed for sustainable construction, but based on life cycle analysis and the circular economy. And we have a series of macro objectives or macro indicators with respect to thermal comfort, which is necessary, of course, but also the life cycle analysis of materials, the social component, and also the economic pillar. And if we ignore this dimension, we're going to be doing things, but it will only be at the end, we'll end up producing more emissions and aggravating the emissions. And I always use the same example. Biomass boilers are wonderful, a good option even for achieving better certification from a dwelling energy perspective. But if we're having to import the pellets from Sweden, what in the hell are we doing? If we perform a life cycle analysis of a boiler in a building in which the heating system consists of a biomass boiler, it's different if we import the pellets from Sweden or if we use local pellets using our local resources. You'd be surprising to see that we could obtain good energy certification levels and perhaps produce more emissions than if we're using other fuels like fossil fuels. We'll be really surprised at the results. But nobody bothers to perform this type of overall or global analysis. So I really think that we have to start thinking that when it comes to renovating a building, it has to be done in accordance, taking into account the life cycle assessment, so that elements are easily disassemblable, that the elements can be easily recycled, and that there are buildings that can be adapted very easily to different needs. Even using interior dividing systems which make buildings easy to disassemble and to change. There you can save on natural resources and energy. So everything is all very well and good, and energy is clearly fundamental. But this has to be accompanied evidently by all of these other aspects which are necessary for sustainability. So that's my final concluding reflection. And I think what you mentioned regarding flexibility is important, that architectures and users don't demand this, for example, in public dwellings, and they should do. So the paradigm is changing. Do you have any final questions or reflections? Ana, Rafael, Jose Sanchez, Valentin, the participants.
Sí. ¿Ya? Sí. Bueno, agradecer.
Okay, I would like to thank all of the panelists for making this effort to try to address all the problems that we face. And I'd particularly like to congratulate those of you who are up on the stage at present. I'm not going to repeat things that have already been said, but the comments made by Rafael prompted me to think of something else that's very interesting, and he referred to architecture. And Valentin also mentioned this. One thing is architecture and another thing is construction without architecture. And in addition to all of the data that these tools can provide, there's two sides to this, however. We have to make sure that they are effective, but we also know that data evolve and may contain errors. One thing that's been ruled out with tools, as occurs now with smartphones, because nobody remembers their telephone number anymore, one thing that we have to maintain is common sense. And this is done in communities through participation in the minds of architects. And architects may be better or worse, but they always have to maintain this social commitment that's maintained in their designs. So what I teach my students is that the first thing that's necessary for something to be efficient is that the project has to be responsible, because just as a patio may be well designed or poorly designed, the same applies to architecture. And we can all do patchwork to resolve problems, whether it's from an energy perspective, or one thing that Rafael said is also very relevant. Coordination is fundamental. We need to have sufficiently in-depth debate. It's not a question of people coming to conferences and telling us what they do, their little projects, because I've written down many, many names, because we do have a project in mind. We do have a project underway, in fact, as Montserrat mentioned before, with everything that can be disassembled, flexible and movable. And we hope that we also have to develop an Andalusian prefabrication industry. And I'm delighted to have met so many people here at the conference, and I hope that we're able to achieve this level of communication amongst all of us, because the matter is urgent. But I also think that we need knowledge. The problem is that much of this knowledge is perhaps less visible. Thank you. That's just a final comment. Thank you. Would anyone else like to say anything? Okay, well, given the time, I am going to wrap up this round table on best practices, the Second International Congress on Innovation, Sustainability and Social Housing being held here in Granada. It's been a wonderful round table. I think it's great that this event's been held here in Granada, because I'm from Granada, but also thanks to the high level and quality of the speakers. Thank you and congratulations to everyone.
Buenas a todos. todas las cosas que he escuchado, ¿eh?
Me he quedado con lo de la
Súper
orientación, que
enhorabuena.
una más, que otra menos. Aprovechemos,
Súper enhorabuena.
vamos a comer, intentemos ser...
We're going off for lunch, and please be back on time so that we can start again at 4 o'clock with the next block of presentations. I would like to ask the speakers for the next block to come a little earlier so that we can prepare the presentations. Thank you. See you later.